this is our first or our inaugural kickoff of NCGU. It's real important to us that we're developing ourselves, refreshing ourselves, getting better. Right? We are builders, so our goal is to set out for excellence in the things that we build and to become the experts. So it's kind of hard being general contractors. I mean, you have your drywall trade, you have your concrete trade, you have tile. I mean, these folks do those things specifically day in and day out. They can really become experts in what they do. As general contractors, we kind of have to be experts at the whole gamut, right? Because we're out there being responsible for supervising these folks, working with them on their schedules, making sure that they're installing things with high quality, high excellence. So we have to kind of have experience in all of it. So thanks to Richard and Joe supporting us, creating this training forum. We're going to set out to really hone in our skills and be experts. If we're going to be builders, we need to be the best game in town. We can only do that if we continually are getting better and improving. So I know some of this may be an old hat to some of you, it may be information, but guess what? It's just a good review. It's just to keep our axes honed and our blades sharp. So when we're out there doing these things, day in and day out, we're doing them with excellence and helping the trade partners do their jobs with excellence as well. So in our training efforts, we're going to look at technical skills, which is what we're doing today. Concrete. Those are the things that we do out there that we're actually building. We have these technical skills. I think we'll call this building block training, our core competency skills in these technical skills. We also have some other areas. We've got some operational skills. I mean, we're talking about Procore, daily logs, schedules, those types of things. So you'll see some more training in those operational areas. And then we have what we call power skills. And these are our leadership skills, communication skills, conducting meetings. I mean, we all have experience out there, or some experience out there, conducting OAC meetings and writing emails to architects and owners and those types of things. So those are the power skills. So we've got 3 areas. We're going to try to really zero in on those. Today we're talking about the building blocks, those technical skills. We're leaning heavily on Richard. Richard, man, and you all just, we can give him a round of applause right now because I guarantee you by the end of this, you're going to be super happy with what you get from Richard. But Richard is a wealth of knowledge. He's got tremendous amount of experience. I know I'm not telling you anything that you don't already know, but moving forward, we are really going to lean on Richard to help us with these building block technical skills, right? Because he is one of our, if not top expert in these things. And I know you all have some expertise in a lot of things too, and I may be looking at you all to help lead some of these trainings someday as well. But anyway, I'm glad you're here. Thank you for taking out the time because I know it is hard to tear yourself away from your jobs. It's hard to tear yourself away on a Friday. This is your day to kind of make everything up for the week, but you did. So thank you. You're investing in yourself. We're investing in you because we want to see Nedderman grow to the next level, next level, next level, next level. And we're not going to do that unless we all are part of this team and all in that continuous improvement mode. So thank you for being here. Thank you for the sacrifice. Joe Skipworth.
Bill says I've got 20 minutes here, so I'll try to do my best. Maybe I'll be short, maybe I'll be long, but we'll see how it goes. One of the things, first thing I want you to do is just look around the room. And what do we see? We see training tables. We see a large team and a large staff of PMs and field people of varying degrees of experience and knowledge and understanding of construction. That's pretty clear, right? But you've never seen this before at Nedderman. but I've had a vision for this, that one day that we would begin to grow and that we would begin to have opportunities, and we would have a training room with training tables and a big touch screen TV where we could bring our people in and actually do training and actually give you guys knowledge, skills, and understanding about your job and what you do and what we do to impart for the vision of the company, because ultimately it's your company. We got some good PMs and some good estimators, but we can sit in here in the office and project manage and estimate stuff out the wazoo. And if you guys, we are not training you guys and advancing your skills and your skill sets and your knowledge and understanding out in the field, we're gonna fail. You're gonna fail. You're gonna look around and go, Joe's put me on a concrete job, a ground up concrete job. Does Joe not know that I don't really know that much about concrete? I mean, I know a little bit, but this is a ground up technical structural slab and foundation. I've never done this before. And you just get a baptism by fire, and all you do throughout the course of that excavation and concrete pour is screw stuff up and have problems. Why? Because you just didn't know. Whose fault is that? Yours? Mm-mm. It's ours. For not recognizing your skill sets, where you are. These guys in the office hear it all the time. You field guys don't hear it, but this is my philosophy in life and in this business, is discover people's strengths and their weaknesses, leverage their strengths, and shore up their weaknesses. Every one of you has strengths or you wouldn't be here. But every one of you have weaknesses of varying degrees. Some of it's based on how long you've been in construction. Maybe you haven't been in construction very long. But the worst thing I could do, or we could let happen to you, is for Austin to come on board, some semi-new to construction, wants to achieve, succeed, and build a career in this industry, but we put him on job after job after job, and we never bring him in here or discover, okay, where does Austin need to grow, and let's develop a career path and a training path that shores up all this lack of experience that he has. One day, I may want to put him on a concrete job. We're just going to go along and he's going to do what he does day in and day out for 6 years, and then suddenly, all right, Austin, this is going to be your first concrete job. He's going to freak out. He's going to go to Chad and go, dude, what do I do? What do I do first? Well, he's been around it, but we haven't been deliberate in teaching, training, imparting the wealth of knowledge. A guy over here who's poured more concrete than probably all of us combined on extremely large and technical projects. We got to get what's in his experience and knowledge base out of him into you. That will never happen except in a room like this or by inadvertent osmosis out in the field one day. When has Austin ever worked closely with Richard on a concrete pour? It hadn't happened. When will it happen? It's going to happen right now, not next year when we finally get around, okay, Austin's going to be on a concrete job. He's going to get to work with Richard. We're finally going to get Austin, after 6 years, some understanding on concrete. No. We can start that now in this room with this training. I probably learned some things from Richard in here. But that's what this is all about, and we're not gonna just do this with concrete, we're gonna do this with all other aspects of construction. Why? Because again, you guys are the tip of the spear. Our success or failure with the clients and our name and our expertise will be determined by you guys in the field. Our clients will look at it and go, yeah, they put a guy on my job that I don't think he knows anything about electrical. They're blowing smoke up my skirt. They put a guy on my job and I asked him, hey, have you ever done this type of work before? Well, yeah. And they ask a couple, and pretty quickly they determine, I don't know about this guy. He answered the wrong answer to about 5 questions. And here's a great example that happened recently. And kudos to Chris. I can't remember, maybe we have, but I cannot remember that Nedderman has ever done a high-level technical boiler project. Certainly, we've never trained anybody about boilers. If you've been on a boiler project and you have an understanding of boilers, raise your hand. And you know why he's raising his hand? Because 2 or 3 months ago, he couldn't raise his hand. He's never been on a boiler. And I had some concerns, and I realized we're deficient. What did Chris do? He took the self-initiative and said, I am not going to fail. I am not going to look like an idiot. Joe hasn't helped me. The office hasn't been able to help me. I'm going to help myself. And he got online and started going through hours of stuff on boilers, the fundamentals of boilers, how they work, what they do, what they're for. Why?
Redundancy.
So that he would have knowledge and expertise, some level of knowledge and expertise on what he's doing. He's on a Bell boiler job. They're concerned about who's doing the boiler because they know there's not a lot of people anymore. Boilers used to be the thing back 30, 40 years ago. I asked Humphrey and Associates who's doing our boiler, when's the last time y'all did a boiler? Oh, we do one about every 2 or 3 years. Why is that? Because nobody uses boilers anymore. There's new technologies in place. Now there's still some need for it and there's still some old facilities that run on boilers, so you've got to have people that are experts in boilers somewhere, but they're not a dime a dozen anymore. It all comes through training. And I've gotten reports from Gil on things that Chris has caught, Gil, the guy at Bell, that Chris has caught that because he immersed himself in the knowledge, on Google and everywhere else he could find of boilers, he's caught several things that were gonna go wrong out there. And Gil's like, man, Chris is the bomb. What's happening there? It's about knowledge. It's about understanding. That knowledge is power. Knowledge is respect. Knowledge is honor. You hear us honor and respect Richard for his years. We all know that within this room, within this company, and probably there's not a lot of people, superintendents, PMs, or otherwise in the DFW area anymore that have the level of knowledge, technical knowledge of concrete. They're out there, but they're few and far between now. We have a wealth of knowledge sitting here right at our disposal that, remember what I said? Discover people's strengths and weaknesses, leverage their strengths. We're gonna leverage Richard's strengths and other people's strengths in this setting, and we're gonna leverage that to knowledge for all of you so that when you go out and you do have a concrete job and a concrete pour, and you end up with an owner's rep or a owner's project manager who is very knowledgeable in construction, you won't feel at a deficit when they walk on the job, or you won't feel like, oh man, we're pouring concrete next week. I know this guy knows a lot about concrete, and I don't really feel comfortable that I am where I need to be. And what are you doing? Oh yeah, I'll see you later. I gotta go look at something upstairs. You're trying to avoid the guy because you know if you start talking to him about concrete, he's going to expose your weakness. I say that from experience because years ago I did it. Sometimes people would come up, the structural engineer show up on the job, and he's looking for me. What if I say the wrong thing? What if he asks me a question that's the wrong answer? You know, eventually I garnered the knowledge, but not because I was in a training. I did it through trial and error and mistakes. And some of the mistakes that I made early on with concrete, Howard, the engineer, what were you thinking, dude? What did they just discover? Wow. You know, he's a great superintendent in many areas, but he has a tremendous weakness. It's pretty clear that he doesn't understand rebar. I remember I had a big technical pour, and I thought my excuse my French, my ass was covered because we had a good concrete sub, and he had subbed it out to rod busters, which are rebar guys. That's all they do all day long, every day. They can read the shop drawings. I can't. I don't even know what I'm looking at. So, sort of, you know, but I don't. It's too technical. So I'm like crossing my fingers that these concrete guys and these rebar guys understand what they're doing at a level that's beyond me, because I don't. It looks right to me. Look at the plans. Okay. And I even went out there and tried. I took the shop drawing, trying to understand, okay, is that the right bar? Is that the right size bar? Has it got a hook on the end of it? Is it turned the right way? No. But I did the best I could. And I thought, okay, these expert guys that installed this, looks like they're doing a good job. I think they did it right. I looked at it. It looks right to me. Project manager comes out, hey, let's go walk the slab and look at all the grade beam rebar before this concrete pour this week. Sure, grabbed the shop drawings. Fortunately, he didn't put them in my hands and ask me questions. He just took them and he walked the forms. That bar's wrong. That bar's turned the wrong way. All these are wrong. That's going to have to completely come out. I felt like an absolute idiot. And I was counting on the rod busters to cover my butt. What's wrong with that scenario? Is it just Joe's fault that Joe's stupid or inexperienced? No, it's that they didn't provide, the company didn't provide any training. They didn't even ask me. And even if they did ask me, I would have probably not told them the absolute truth that I really don't know what I'm doing at all with rebar, which I probably should have, but I was trying to wing it. But it has to do with training. It has to do with somebody like Richard has to sit down with you and go through the shop drawing and read. This goes here, that goes there. This is what that symbol means right there. Is that a hook bar and it needs to turn to the left? And you go through that stuff over time like that with somebody who has knowledge. Now you're not an idiot. Now you have knowledge. Now the subs come to you and say, hey, you see these shop drawings? I'm not sure if I'm understanding this right. Come here. Yeah, no, that's not right. You need to take those bars out, turn them over so the hooks are pointing down, you know, et cetera, et cetera. Those are just a few examples of hundreds of examples I could give you. But herein lies one of the biggest problems and the biggest needs for this type of training and ongoing. That's why we're calling this NCG University. We need to make sure that you guys have the knowledge and the skill and the understanding and are in a we talk about continuous process improvement. You guys are a continuous process improvement. We need to be investing in you and your knowledge base and experience and bringing at a quicker pace, not by trial and error experience like I learned it. I say this all the time. One of my sayings is, my ceiling can become your floor if we do something like this. But in this industry, the mountain that we're looking at is monumental. I've had this discussion with other people in the office. I don't know of any other industry that really technically requires you to be an expert on a nice sized project. It's going to require you to be an expert at earthwork. You need to know everything there is about earthwork, compaction testing, types of dirt, etc. Richard's going to go into all this stuff. You need to know everything there is to know about concrete, structural concrete, pours, the technical side of it, the practical side of it. You have to be an expert. You have to be the guy on the job that knows more about it than the subs do. You have to be the guy on the job that actually knows more about it than the architect and the engineer do. They know how to draw it, but they don't know how to get it done. You have to become an expert at interpreting structural drawings. You have to become an expert at the architectural drawings, being able to read the blueprints and understand what it's saying. You have to become an expert at HVAC. You have to become an expert at electrical. All these are disciplines that other people, that's just their focus. There's HVAC mechanical engineers and HVAC contract. That's all they do and that's all they worry about. But you have to be an expert in that as well. It's ridiculous. You have to be an expert in estimate. Ask Ed. Ed, in estimating the jobs, he's looking at proposals and materials and specifications for everything from civil engineering all the way through project closeout. You have to be an expert in every aspect of construction where nobody else on the team really does. That's a ridiculous requirement.
Well, and the biggest thing is coordinating all those different subs.
Yeah. But, I mean, people choose a career path. They go out there and say, well, I'm going to be a structural engineer, or I'm going to be an architect, or I'm going to be an HVAC guy, or I'm going to be plumbing, or I'm going to be piping, or I'm going to be civil. They're specializing in one of those areas. We are expected to be expert in all of them. We're expected to know as much about structure, earthwork, civil, structural, plumbing, mechanical, boilers, but it's ridiculous the expectation that's placed upon us to be an expert in every facet of construction. It's ridiculous. And take it to another level, I'm expected to be an expert in all those areas. I'm expected to be an expert in estimating. I'm expected to be an expert in AIA contracts and legal issues and law. Bill Green, because of this, he's working his knowledge in all these areas: structural, civil, plans, technical jobs, electrical, mechanical, you name it. And then on top of that, he goes out and gets a 2-year law degree in construction. It's ridiculous the expectation that's placed on people in the construction industry. So if that mountain is that big, and remember, knowledge is power, knowledge is strength, knowledge is success. This is the mountain of knowledge that we as a construction company, in order to excel and exceed and at least be equal to or better than our peer general contractors in the area, how do we set ourselves apart? when we've got to climb this mountain of knowledge that we need to have in our skill sets to actually be able to exceed our competitors. Training. NCG University. Bringing people in like Richard and Henley Johnston, and we're going to bring in WJE at some point on waterproofing. Those guys, that's all they do is waterproofing. For the most part, their waterproofing division. That's their singular focus. But yet when we build a job, the owner and the architect and everybody's expectation is for Alex to be as knowledgeable as WJE on waterproofing. Well, he's not, obviously, right? So what did we do? We have to mitigate that risk. We bring in WJE to work with Alex on his job, to vet his drawings, to make recommendations, to go through it with him, and they download into Alex's head what they know about waterproofing specific to his project. Now, last year, maybe he didn't know a lot about waterproofing. Now, he knows a whole lot about waterproofing, but there's still a lot more to learn. All of you need to understand, what is it? What's the waterproofing? What's the ratio? It's
70%.
It's 5% of the budget and 70% of the lawsuits. What does that tell us? That tells us that waterproofing, every one of you needs to be an expert in waterproofing. You need to be able to walk your jobs and see a detail going bad because you have knowledge and experience and you can identify that's going to leak. That's got to be resolved. How are you going to be able to do that unless you're an expert in waterproofing? How are we going to try to shore up your weaknesses in waterproofing? By bringing in WJE onto your job or into this classroom training setting, which we're going to do. So that's what this is all about. We've never had this before. We've been operating the other way by the seat of our pants, crossing our fingers, hoping that our people in the field have the experience, knowledge, or understanding, and that if they don't, we're also hoping that our subs will cover our butts and they'll figure it out and not put things in wrong or do things wrong. That's a terrible way to do business. That's fraught with risk and potential lawsuits over and over and over again, and a reputation on the street ultimately that will be, yeah, I don't know about Nedderman. Every time they do a job, they have a leak. Every time they've done a job for us, they've had a concrete failure that we had to tear it out for some reason or another. And it can be catastrophic sometimes. Just the simple knowledge, we'll get into some more stories, I'm sure. Superintendent, they're pouring a big pour. It's 20,000 square feet of concrete structural slab. Everything's going asses and elbows and 100 miles an hour. Get pour set up, they start pouring. Woohoo, man, we poured concrete. The first break comes back. It doesn't meet 4,000 PSI concrete. Well, is that just a bad break? Start doing it. No. You know what happened? Crossed wires, the concrete supplier and the concrete contractor didn't follow the approved submittal, and somehow they sent the wrong mix design. We're supposed to have a 4,000 PSI mix design on this 20,000 square foot slab, and we just poured and finished, woohoo, a 3,000 PSI. Guess what? It's all coming out. When I started in commercial construction as a laborer in Midland, Texas in the 80s, the contractor I worked for got a contract for multiple additions to multiple elementary schools, and they set it up where they would be able to pour in succession. It was one big contract, 9 school foundations, additions. The concrete supplier that the concrete contractor used had some kind of issue with his plant during the 2 weeks that we poured this slab, this slab, this slab, this slab, this slab. Not one slab met specification because they had a problem in the plant with their equipment and they didn't even realize it. And they supplied concrete that didn't meet strength. Every slab's got to come out. The concrete supplier and the concrete contractor went bankrupt. It's all over. One job. The general contractor managed to survive, but it was years for them to recover financially. 9 slabs, I forget how many millions of dollars it's off. Everybody's celebrating. We got the 9 slabs in. Today you're a hero, tomorrow you're a zero. Why? Where's the root cause? Well, in that case, it was with the plant, but it can be where superintendent didn't check the mix design. Superintendent didn't know how to read the ticket where it should have said 1.5 inch aggregate and it said pea gravel. And he poured the whole thing with pea gravel. Those are just little examples of what we're talking about and why we're here and why we're in this class. It's for you to give you knowledge so that you can succeed. And if you succeed in the field, we will succeed. So that's all I got.
Yeah, Joe built up quite the expectation, so I'm not going to be able to make you all experts in everything I know in the time we have. Sorry. So I kind of wanted to start this with dirt work and excavations. Bill wanted to focus on concrete, something we're doing all the time. But the truth is with concrete, you're not going to separate the dirt work. You're not going to separate structural steel. You're not going to separate all the different machinery and embeds and all the stuff that comes into it. So let's just look at does everybody have one of these? So what I started out with is Joe telling me to make a concrete checklist and then Bill telling me we're going to do a training class. So I just started writing this stuff off the top of my head. The first sheet is basically just general basic reminders of what we're doing to get ready to pour concrete. I've got a 6-week look ahead. That really should just start the day you get the job. We've got a concrete pour checklist. Let's go to the next page. I couldn't put everything on that concrete checklist that had to do with every different phase of concrete you might be doing. Piers, grade beams, slabs. So these are just reminders, and I wrote, just Piers 101 because that's all it is. It's just basic reminders of what you're doing when you're doing piers and reminders for grade beams. A lot of this stuff I did get some training on when I started commercial, and then the rest of it was the way Joe described, by fire and in the field. And every mistake is a training class. You start becoming experts right after you mess up, and you got to figure out everything that was wrong. Slabs, elevated slabs, concrete columns, concrete paving. Bill suggested that we start with this back page, which is basic info, and what I wrote was how-tos and general notes. And basically where this came from was after I wrote the list was all the stuff I kept thinking of that we also need to know. So it all starts with the geological survey report. The structural engineer will design the foundation based on that. In that geological survey report where they do the borings and soil samples, people much smarter than me, I have no idea how they come up with what capacity, what pier will hold, or It's all on the plans, and the best thing you can do, read the geological survey report, look at the recommendations, and read the structural plans. All the notes on the structural plans. Structural more than any other electrical or mechanical, they literally put their specs right there on that first sheet. You can read everything you need to know for that job. Now, these are really just basic things here that I've wrote down. I assume everybody knows how to calculate and figure how many cubic yards they need for a concrete job. If you don't, Construction Master Calculator. Who has that on their phone or has one? You don't get a mug if you pull it up on Google. Download the calculator on your phone. Does anybody have any questions about how to calculate cubic yards of concrete? I mean, I kind of wrote the formula there. So you're going to be working in feet, then you're going to need to convert it to cubic yards by dividing it by 27. 27 cubic feet in a yard. Okay. Does everybody know how to figure concrete for a pier? That's everybody? Okay. All right, I'll tell you, that's a simple thing that I wrote down there that I just happened to run across. On a 2-foot pier, your radius is 1 foot. So when you're figuring area of a circle, you've got pi r square. So if this is a 2-foot hole, the radius is going to be 1 foot. So when you take 3.14, the pi part of pi r square, times 1, you're going to get 1. If you've got a 2-foot, I'm sorry, 3.14. You're right. I wrote it on there, but I can't say it. So if you've got a pier 27 foot deep, after you figure this area, you're going to multiply it by 27, and that's going to give you how many cubic feet. But to get back to yards, you're going to divide by 27. So you're right back at 3.14 yards. If you can remember that, you could plug in whatever number you need to here.
Much better.
Is there any questions on that? Okay, cool.
If we gave you a test, would you be able to do that math right now? Or is everybody just being shy? Because we don't need to be shy in this room.
Okay.
If you have a question, make sure we're participating and asking it. Don't feel silly.
Everybody understands rebar sizes? Basically, the easiest way for me to remember it's what I wrote here. Number 4 is 1/2 inch, and it goes up 1/8 inch for every number. So a number 10 rebar is, right. Everybody? Okay. Well, I know some of us don't always know all of it. Rebar splicing. Is everybody familiar with all the notes on the structural drawings? They're going to tell you bar diameters. So I literally wrote the example out there. Austin, you good with that?
Yes, sir.
You are quick. Okay, does everybody know how to figure a diagonal when you're trying to make something square? That's 81 feet, 26 feet. What's the diagonal that proves that That's Pythagorean. A squared, B squared equals C squared. Okay, because I had the calculator, I put it in. It's 85 feet, 0 inches, and 7/8. A lot of people will just get in a corner and go 3, 4, 5, 6, 8, 10, and they've got these points that they've got to extend out. You don't have to. Just put the numbers in. It'll come up more than you think when you're laying out. All right. On the Construction Master calculator, what I use is, just like I was cutting a roof, is rise, run, diagonal. You've got it on yours? All right, up on our screen, when you're doing layout, all your details on structural are going to be based on these grid lines. There's your anchor bolt. Your anchor bolt setting plan is going to show how your anchor bolt sits to that grid line. So the first thing you want to do, and this is different than residential, is have your surveyor lay out the grid lines with offsets.
Richard taught me that at Grapevine in 2019, because I was residential before that, and I would go out and lay out the building corners. Guess what happens? What happens when you do it that way, Richard? They come out and they start doing dirt work and grading around, and the corners are gone.
Yeah, they really are gone. Put your 10-foot offsets, figure out how they're going to work with things around the building. You might have to do a 15-foot offset, whatever works. But the main things with commercial is work with the grid lines. All your structural is going to be based on those grid lines. All the dimensions will be off the grid lines. Residential, it's outside building lines. Architectural, they hardly ever do enough dimensions off grid lines. But with structural, it's all about the grid lines. Let's see where we're at. You got another picture too?
Yep.
Let's blow up that, well, let's blow up that bottom corner right there. Y'all see that pier?
Hold up. This one?
No, I was back on the other page right before you closed it. Yeah, go to that bottom right corner. There's everything you need to know for that pier. It's an 18-inch pier, 36-inch bell, 24-inch pier, 48-inch bell. That's typical unless noted otherwise. Those elevations, that's the top of your pier is 99. All your plans are going to call finished floor 100. And they do that so they can write subgrade numbers that are not negative. So that's a foot below finished floor. On the interior piers, that's going to be where your columns are on the interior. On the exterior piers, they're below the grade beam, 97.4. How far below floor is the top of that pier when you stop pouring?
2'6", Richard.
Close.
I wasn't on it.
No door prize for you. 2'8".
Oh, 6'8", thank you. I was looking 10, not 20.
Yeah, I know. Well, no, that happens a lot.
Yeah, there we screwed up all the piers on my job just now.
So your 2'8" down in a hole is the top of your pier. And somewhere I think I wrote on here, one of my tricks is how to make something that'll help you shoot that elevation in there. Go to that next picture. Okay, on here, just look at where the grid lines are. Blow up any detail there, it's got a grid on top of it, a circle. Go down a little bit. You see where that circle grid is, how it's centered on that anchor bolt? Go down a little bit.
Scroll down. A little bit more. A little bit more.
A little more.
There you go.
There it is. Do you see what I'm talking about? When you lay out that grid line, you know where the outside of your footing is. It's 1 foot out. And you've laid out with precision where the anchor bolts are. Not all anchor bolts center on grid lines. You've got to look at the details on it. Some of them are offset. Each one matters. Do a basic check of your structural drawings. You'll be surprised what you can find comparing back and forth, looking at structural and architectural, starting with grid lines. I found dimensional bust where the structural just decided to add grid lines that dimensions didn't work out with architectural.
If you have a pre-engineered building, don't look at the architectural structural drawings, look at the pre-engineered approved shop drawings.
There you go.
And bear.
Yeah. Shop drawings are a big part of this. But if you're, as you're looking through there, I've on several buildings found a wind brace right through a door or a window. The architect draws up his plans. Structural takes those and does the structural part of it. It happens. It's better to head it off, but I have found that when the structural guy makes a mistake, that wind brace can just go away. It's not even needed. If you make a mistake, tear it out. Yeah.
Richard, while you're on that, remember on bid 27, the structural plans had the roof curves at a completely different location than the architectural plans.
Yeah, no, that's a
And it was
coordination.
our job at Nedderman to verify that was wrong and get a request
Yeah.
for information from the architect. And
Right.
we missed that.
Yeah.
So that important.
Right now, he's right in shop drawings and submittals and all that, but we're focusing, trying to focus on concrete because there's a lot of bunny holes. The time to figure out that those wind braces and the structural's wrong and your anchor bolts is whenever you're doing the concrete because you're trying to coordinate the two. Crack control. Everybody knows, I thought everybody knows, to make sure you have diagonals at corners in your slab or in your blockouts. So if you're pouring a slab and you've got a diamond out here that's got anchor bolts and a pier below it, you're putting rebar this way, 2 layers. No matter what your overall grid pattern is, these just go on top. Anywhere you have a corner, here's the slab turns. This is a corner. You got all your rebar in there. You're putting diagonal bars. When this tries to crack right here, that's going to hold it together. That detail's on your drawings. So like I was saying before, if you'll just read the structural and look at the details. But when it comes to crack control, and that's what we're looking at here, make sure those diagonal bars are in there. Another thing with crack control are cold joints or adding water to the mix on site. Cold joints happen whenever you got 35 yards to pour. They order 30 just to see what they got left, and you wait 2 hours for that last truck to come. And here you've had this concrete setting up that you're just going to tie into. It's better to just order the 40 yards. Concrete guy doesn't like to do that. He wants to see exactly how much is left. And then there's 5 o'clock traffic. and then dispatch it, yeah, the truck's coming. Truck ain't coming. Typically, on your structural drawings and in your submittals, you're going to see you need to pour your concrete within 90 minutes of when it's batched. The batch time comes on the ticket from the truck. The farther away the truck is to start with, the longer it takes to get there. traffic in the morning's a problem. That's why we end up with so many early morning pours, is to avoid the traffic, not to mention usually the hot weather. Do have a hot and cold weather concreting plan. We'll cover that in mixed designs a little bit, but in cold weather, if you can use a high early or an accelerant, they'll say a non-corrosive accelerant. They used to be corrosive accelerants that ate the rebar. That was even before my time. Vibrating concrete. Vibrating concrete's great, especially around the perimeter. But whenever you're moving concrete in a grade beam or whatever, let's say your truck won't reach the last 10 feet and they're just sitting there vibrating it and vibrating it to make it go down. They're just separating the cement from the aggregate. Your aggregate's piling up right there and only your cement's going down. Vibrating's good, but too much or too little is a problem, especially way too much. So.
Hey, Richard, stop right there, just for the benefit of these, Austin and Jose, do you all know what, when he says aggregate, what he's talking about?
Like the concrete's like spreading out.
The gravel.
Yeah,
Right.
so the concrete is a mixture of the
Portland cement,
and
sand, and rock.
rock, so that.
Usually limestone.
Alright, so what he's talking about is if you're vibrating that concrete, then all those rocks are settling to the bottom and you're losing the strength that they provide at the top of that slab.
And the concrete is also pushing west or wherever, leaving the aggregate in place is what the big problem.
Yeah, when the grade beam.
Juice.
Right.
Yeah, you're just moving the juice. You're separating it.
All over there and left the dirt.
You're separating it, and they do that. And here comes the concrete truck, and the finisher out there whistles to add 15 gallons. You don't even know that happened. Adding water to the mix makes it less strong. It's going to show up in your test cylinder. It's going to show up in cracks in your slab. It might make it flow. Yeah, it might make it flow better, and that's what he's looking for. Well, to do that, and you're add a plasticizer, a mid-range plasticizer. We'll get into that with the mix design a little bit later. Let's go to picture 3. So, pumping concrete, how far can you pump? It's typically 50 meters. You can get a 53-meter truck, but if you look at that pump, you see he's pumping uphill. He's pumping over a mountain, then it comes out. So when you're dealing with a line pump, you don't have that head pressure. You're going straight, so you can go much further. And so we found out, on our foundation, how far can you pump with a line pump? Well, with a line pump, you can typically 150 meters.
And that's the one that's just laying on the ground.
Just laying on the ground. And that line pump could show up on a trailer, or it could be this pump that's got a connection off the side. So what really determines how far you can pump is that head pressure, going uphill or not, or just flat, but also the size of the pipe. But one of the biggest things is the aggregate size. The smaller the aggregate, the farther you can pump. That aggregate really gums up inside a line when you're trying to go a long ways. When you start pumping like this, the first thing you're going to do is pump a yard of grout. On a big pour, we usually just let that spread out in the bottom. That's the end of it. If you're on a small pour or it's critical, you're going to have a place to contain it. On a job like this, that wouldn't be a problem. We just pump it right off the edge of the slab. They put a bag of slickum in there, and it just primes the pump so concrete's not trying to stick to it and pump grout. So your first truck's grout. If you're used to pumping concrete all the time, you already know that. If you don't, at least you have some idea what's going on. So, So I did put down some options here on how to pump farther with bigger pipe, less aggregate, or smaller aggregate. The plasticizer, you know, I was talking about putting a mid-range in to pump. If you're gonna be pumping a super long ways, you might need to put in a high range. What the plasticizer does is it increases your slump. A mid-range of 5 slump turns into a 7. It has the same water as a 5, but the slump's a 7. A high range increases it by 4. So your specs say a 5 slump, now you can do a 9 slump. I mean, that's pretty watery. That's but that's the deal. Now, I was doing a linear accelerator for Sightline in West Houston, and what that is a concrete treatment machine, and it's got 4-foot concrete thick walls all the way around it. And we had a high range. The pump guy pulls up there, put concrete in, he sprays it with water. All the sand and cement and all these mixtures whoosh, went away, and it just a pile of rock in the hopper. Done. Pump's completely clogged. 4 trucks sitting there. So I'm scared of high range. We used it on our job, on that big foundation, didn't have any problems. But for God's sakes, if you're using a high range, pay attention, because that guy's just used to regular concrete, and he sprays a little water to help get it going, which is, again, messing up your mix design. But he's just, you know, the first truck. So yeah, there's some horror stories. Super flat slabs, there's no way we have enough time to cover everything here. That was pumping a long ways there, and you can see all the rebar on that foundation. That's a line pump. There we go, super flat slabs. I had done one of those on that Fine Arts Center. It was a TV studio. We talked about doing it in strips. We decided it was only 28 foot wide. We could do it with a power screed. Didn't work out too well. You have to do a super flat slab in strips. Chris has got a lot of experience. His was small enough they got away with it because they had enough guide rails and stuff. And your flat, that's the whole thing right there. That right there came from one of our consultants. Mark, you remember which one it was? It was our guy down in Florida.
That basically came from a company that did a lot of super flat orders.
Yeah.
It's Eldon Tipping's field guy.
Yeah, what's that guy's name though? He was the actual their consultant, Bob. So this was new to me. What we've got here is a flat piece of metal. The form is set a 1/4 inch low, and that's a milled flat piece of metal. And we've shot it on there with a real high accurate instrument. Now you're only pouring 10 feet wide, and you've got that to screed across.
Yeah, it's actually down on the plane.
So it's a game changer. So let's see if we got another picture. We got a video. So what we're talking about here is super flat slabs. That's the instrument right there. That thing shoots within a millimeter in 300 feet. The shot stick doesn't even have numbers. You don't even read it. It's got a barcode. You wiggle it back and forth. It automatically calculates the shortest distance for accuracy. You know, if you don't hold your shot stick plumb, it's a longer distance. So that's a real smart piece of equipment. Hit that again. You can see we've got 2 ride-on troweling machines on a strip that's 10 feet wide. That is to really knock it down flat. And what's different on super flat is you don't try to do anything with it until it's already too hard to do anything with. You've already scraped it flat, scraped it, and you just wait, and then you throw that on there and knock it down. It was quite the experience to do that, and then to come back with the results we did. Everybody was pretty much amazed, including myself, because my first go around with super flat, like I said, didn't go that well.
And I just wanted to, we kind of split this up into 2 things. We've given presentations like this before to other construction companies and superintendents. We like y'all better though, I'll just tell you that. They did not get the books, actually. They did not get the books. I'll just say this is what we want to try and convey to y'all is, hey, these are a lot of the issues or questions that we get asked by construction managers, project managers, superintendent, foremen out in the field. And so this is not meant to be a real in-depth lesson on soil and concrete, but it's meant to say, hey, these are some of the issues that we see, and we just want to be able to impart some knowledge to y'all as far as what we as a testing laboratory and a geotechnical engineering firm do, and hopefully, you know, if there's an issue that comes up in the field, we can both be speaking the same language. When I was at A&M, I was taught there's three good answers, or only three acceptable answers. One is yes, sir, no, sir, and the third is I don't know, but I'll find out. So if there is a question on anything that y'all have, whether it's, you know, if what this presentation that's going on today, whether it's something out in the field that's related to what we do, please do not hesitate to pick up the phone or text me or Bobby or whoever your assigned project manager is and say, hey, I've got a question, I've got an issue, what can you do to help me resolve it? And we will do our dead level best to help you. Okay. I'm going to go over testing and evaluation of soil in the field. So if we could get the next slide up. All right. I just want to kind of give a real, very simple primer on what soil is. And soil is anything that is naturally derived from the Earth's crust. And so we've got, you know, there's things called peat, which is basically, it's, well, I take it back. That's not, it's classified as a soil, but it's not derived from the Earth's crust. But for our excavation, I mean, for our intentions for construction engineering, you're going to have soil, and that is, we look at soil from an engineering construction perspective as, okay, what is its engineering properties, and what is its construction abilities, or purposes. And we're looking at that as, okay, how much load can we put on this soil? Think of foundations. How much load can we put on this without it settling too much, and then all of a sudden we have issues? How easy is it to excavate? So in other words, are we gonna, what size of a piece of equipment are we gonna have to use? Are we gonna have to lay that, can we lay it back on like a 1.5 to 1? Are we gonna have to do a 2 to 1 or 3 to 1 to create a safe slope? We're looking at also how permeable or impermeable it is, depending on how we're gonna use this soil. Are we gonna use it to line a pond or to cap behind a retaining wall? Or are we gonna use it for some type of a subsurface drainage system? And then here in the North Texas area, we're also going to look at how expansive is this material. Texas, you can either look at it this way, is Texas is either blessed or cursed with an abundance of expansive soils. We have, there's other pockets in the United States that have some soils that are, I would say, slightly expansive, but nothing like we see here in the Texas region, and pretty much from like the Sherman-Denison area all the way down into Laredo and Eagle Pass. You've got this nice wide band of expansive soils, and that happens to be where most of the development in Texas occurs. Soil, if you're looking on a field density report or a moisture versus density relationship report, soil is going to be described by the grain size, its color, its texture. So in other words, does it feel gritty? Does it feel slick? And then it's also going to be talked about in its proportions. You can have the wide categories of soil that we deal with. You've got clay, you've got silt, you've got sand, and you've got gravel. Well, you can have different proportions of that. You can have a clayey sand, you can have a gravelly clay, and it just depends on what is the largest percentage by weight of that particular soil type in that sample. So in other words, if I took this bottle, if this bottle was, let's just say this is a sample of a soil, and it's 30% clay and 70% sand, I would call this a clayey sand. consequently, if it is, let's say it's 70% gravel and 30% sand, I'd call it a sandy gravel. You know, for engineering, for an engineering type classification. The main system that we use, we as engineers, or I as an engineer use in classifying soil, it's an ASTM standard, and that's American Society for Testing and Materials. And it's also commonly called the Unified Soil Classification System. And it can get into, you know, there's different things as far as, you know, hey, what's the angularity or what's the shape of the soil particle that you've got in there. But for y'all's purposes, I just want to go real quick as far as how soil is broken down. All right, we're clays, you know, we've got clay, silt, sands, and gravels. Clays are less than 0.0002 inches in diameter. So in other words, to be able to see an individual clay particle, you're going to have an electron microscope. If you were to pick up just a bucket full of clay, there would be billions of particles inside that bucket. To us, it just looks like all one mass of soil, of material, and that's what it is. But each of those is all these, I don't want to call them microscopic, but they're very, very small particles. And when they get that small, you actually start to develop, and I'm going to ask you to think back to your high school chemistry and high school physics class, they'll actually start to develop a charge on them, just like an atom would. And so you can have some clay particles that have a very high affinity for water, because water is actually a charged material, and so they'll bond together with that water. Just like lime will bond to clay soils, it's because it's a chemical reaction, because that clay actually has a charge to it, a negative or positive charge. Silt is the next material up from a clay, and I would say is, if you're going to try to envision what silt is, think of bread flour. The processed flour, like you go buy at the store, that's about the particle size of a true silt. Here in the Dallas-Fort Worth area, we very rarely come across what I would call a true silt deposit. Every so often you'll find something like that, like out in the mid-cities area, you know, in places just kind of in a north-south line from mid-cities. Every so often you'll find something like that.
Hey, James,
Yeah.
is that like in that same phylum right there, is that loam also? Or is that a
Yeah,
different-
well, loam, I'll put it to you this way. There is, you can classify soil for engineering and construction purposes, and then you can also classify it for agricultural purposes. And the term a silty, sandy, loam, and I forgot, because I don't deal with it all the time, I don't know all the terminology, but loam is an agricultural term used to describe soil. So
Yes,
like,
I'm originally from Arizona, and there's just loam everywhere. And
Yeah.
It has nothing to do with agriculture out there. It's-
yeah,
it's a
loam.
problem.
Yeah, loam in this area would be kind of considered like a silty sand with some clay to it, or like a loam. The way I was taught in this area is it's going to have probably very even proportions of sand, silt, and clay to it.
Okay.
You know, and because of that, that's what makes it good for growing things in. Sands are between 0.005 and a quarter inch in diameter, and they're actually broken down into 3 different sizes, which is your fine, your medium, and your coarse. And think of fine sand. On the lower end of the scale, that would be your frac sand. Up to your medium to your coarse sand be something that you would find in like a ASTM C57 stone for your concrete mix. So, and then also your medium sand would be something that you would think of like for playground sand, just as a comparison. Can I see the next slide? Yeah, thank you. All right, now gravel. Gravel's anywhere from about a quarter of an inch to 3 inches in diameter. Think of, if you go to your landscaping place, think of bull rock. That's going to be your top end edge of your gravel. And gravel can be separated further into fine, which is your quarter inch up to 3/4 inch, and then up to your coarse, which is the 3/4 inch up to 3 inches. just about all of the concrete mixes that are going to be produced here in the Dallas-Fort Worth area are going to use a fine gravel. So in other words, the largest stone size that you're going to have is 3/4 inch. Right. And then just so for your own interest in education, there's 2 other classifications of soils by particle size. That is cobbles. Cobbles are anywhere from 3 to 12 inches in diameter, and we never run across, in my experience, we've never run across that here in the North Texas area. Maybe you might find it along some of the old river channels. You find it now, like you get around Waco, Temple, Austin, San Antonio, places farther south, that's when you start encountering cobble-sized materials. And then boulders, which are 12 inches in size or greater. Okay. Can I see the next slide from you? Okay. Field density testing. There's 2 ways we do that in the field. It's either using a portable nuclear gauge or using drive tubes. I'll talk about the drive tubes real quick because that's a very simple type test. We've got a steel cylinder. We take it out into the field. We drive it down into the subgrade, that fill that's just been placed. We dig it out. We trim it off at the top and bottom. We weigh it there in the field. Then we wrap it up and take it back to the lab. And we'll put it in the oven overnight, dry it out. And so because we know the volume of that tube and we know the weight, the wet weight of the sample and the tear weight of the steel tube itself, we can figure out what the dry unit weight and the moisture content of that material was. Now, this is good to do if you've got like a very large earthwork project, kind of as a backup to your field density tests. The what do I want to call it? The shortcoming of this is you got to wait at least 24 hours to get your results. Okay, probably I would say 99. Can we go back? I'm sorry. 99% of all of the field density testing that is done here in this market is done using portable nuclear gauges. That yellow machine down there, kind of on the bottom, on the left-hand side, the bottom right-hand corner of that picture, that's what's called a nuclear density gauge. There's this rod right here. This rod right here, on the tip of that rod, probably about the size of the end of your pinky, is a nuclear source. Actually has 2 sources of radioactivity in there. One is cesium, and the one is americium. And the way it works is you'll drill a hole in the ground, set the machine on top of it, and then you'll insert that probe into the hole. And the machine is calibrated as such as that the machine knows how far down into the ground that probe is. It knows what the intensity of the radiation that's coming off the end of that probe should be or is. And it measures underneath where that red stripe is, there's a receiving unit or a receiver. And it picks up the americium that's coming through the soil. And depending on the intensity of that americium, it tells you how dense that material is. The cesium, what it does is it excites the hydrogen molecules that's in the water, that's in the soil, and starts releasing hydrogen atoms. And so the receiver also picks up the amount of hydrogen atoms that is being excited or being released. I know that this is all kind of deep for you, but depending on the intensity or the volume of that hydrogen that's being released, it can tell you what the moisture content of the soil is. Now, it's going to take and Bobby, correct me if I'm wrong on this. Like if this is our machine right here, it's pretty much going to pick up everything that's just directly under the machine, I forgot what's the distance on either side of it.
Up to about a foot.
Up to about a foot on either side. So if you're in a trench, what you're supposed to do is if the trench is less than 3 feet wide or 4 foot wide, I think, you're supposed to actually run what's called a standard test, which is what you will actually calibrate the machine inside that trench before you take your density test. So that way you'll know that if you're picking up any moisture or density on the side walls of that trench. Okay. Can I go to the next slide?
And that begins at 3 foot wide or?
Sorry, 3 to 4 foot.
So
Yeah.
as soon as you hit 3 foot, you should be calibrating inside the trench.
Yeah, you should either run a trench correction or re-standardize it in that atmosphere, so it kind of
Gotcha.
neutralizes all the interference around it.
Okay, that makes sense.
Now, how are we going to determine how much a soil is compacted? All right. There's in what we do is we use what's called a moisture versus density curve. And I don't know if any of y'all have seen those reports, but it's got the parabolic curve, and it's got dry density on the left-hand side for the y-axis, and the x-axis on the bottom is moisture content. The way we figure those out or develop that is we'll take a sample of the soil, bring it back to the lab, and depending on what the project specifications are and the type of material that is being used, we'll run one of 4 type of moisture versus density type curves. There's others out there, but as far as this is mainly focused on building construction. You're going to have what's called your standard proctor, which is the most common moisture density test that's run here in the Dallas-Fort Worth area, and that's called your standard proctor. The reason it's called a proctor is the gentleman that developed the test back in the 20s, his last name was Proctor, so it became a proctor test. There you go. Yeah, there you go. Yeah, giving it to him. So anyway, you have your standard proctor, which basically was developed to try and mimic the impact or the weight of the construction equipment that was in use at that time. Later on, as we started using larger equipment, another test was developed, which is called the modified proctor, to try and mimic what the weight or the impact, the compactive effort of the construction equipment that was being used at that time. The way this works is with either of these tests, you'll have a mold, a cylindrical mold, you'll have the sample, and what happens is we'll take these samples, we'll mix them up at different moisture contents, we'll let them cure overnight, and then we'll take those different samples with different moisture contents and start compacting them into a circular mold. And with a modified proctor, with the standard proctor, you're going to use a 5.5 pound weight, and you're going to drop it from a height of 12 inches. And you're going to go around until that particular lift is compacted, and you keep doing that until your mold is completely full. And I'm not going into all the details of it because I'm just trying to convey to y'all what we do on a simple basis. Modified proctor, you're going to do 10 pound weight with an 18-inch drop, so you're going to get a little bit more compactive effort. TxDOT 113E, this is used for flexible base, and you're going to have a 10 pound drop with 10 pound hammer with an 18-inch drop, but it uses a different size mold than what your modified proctor does. And then you have your TxDOT 114E, which is used for subgrade, like a pavement subgrade, and also embankment, or common areas. It also has a 10 pound weight and an 18-inch drop, but it has a different size and height mold, and then it also has a lot more times that you tamp the soil into the mold. So those are your 4 main types of tests that you're going to use. And you guys that are taking notes, I like to see that. I like to see the guys that sit up front. But I'll email this to Bill, and y'all can have these slides for your use as well. Okay, let's go ahead and there is one other thing. If you're going to be testing what's like a pure sand or a pure gravel, there is another test out there that's called a relative density test. And the way that works is that you'll get a couple of buckets of that material. You'll put it into a big mold, big cylindrical mold, put a weight on top of it, and then put it on a vibratory table and let it vibrate until it's all consolidated. And that's how you determine what your quote-unquote relative density is. But again, that's only going to be used if you're testing a pure sand or a pure gravel or a mix of just of those 2 materials. And again, that is rarely ever used here in the Dallas-Fort Worth area. Okay, can I get the next slide from you?
Hey, James, when we have a spec to compact gravel,
Mm-hmm.
Usually it's, the PSI that they want is not, that's why we usually send it to you and say, this is what you can possibly do. You send
Right.
it back to them. What is that normal to, I mean, cause usually it's on our stuff's usually at Bell, it's more vibration studies and all
Mm-hmm.
that sort of stuff. But they come back with, they had something, they wanted like 3,000 PSI compaction on, gravel. And I'm like,
Well, you're not going to get that. I mean, that's that. If you look at it, I mean, that's something that's the consistency of concrete. If they're looking the way that if you've got a spec that says, hey, I've got to have a flex base and it's got to have a compressive strength of a certain amount, usually what you're going to have to run is what's called a triaxial test, which is you would take a sample of that material, compact it in the lab, and then put it in a. It's basically it's a cell that's pressurized all around it. So you've got a pneumatic or water pressure that's holding it in place as you compress it. And so what that tells you is that would tell you what the compressive strength of that material is. Now this is the curve that we get from when we're running these density tests, or not density tests, when we're running these, I'm going to call them Proctor tests because that's typically what everybody refers to them. When we're running these Proctor tests in the lab, we get this nice curve that shows up. And each of these points right here was a sample of the same type of material that we took, we dried it out in the oven, and then we mixed it up at different water contents based on the dry weight of that sample. So in other words, if we had 10 pounds of material and we wanted a 10% moisture content, we would add 1 pound of water to it, mix it all up, let it sit overnight, and then compact it in the mold, weigh it, and then dry it out in the oven again. And then when we get that information back, we determine, okay, this is what our dry unit weight is for this particular sample, and this is what the actual moisture content was at the time we tested it. So if you can see here, on this point, when we pounded it out and tested it, we had probably about a 19% on the moisture content, and maybe about, these are maybe about 82, let's see, 85, so a little bit over 82 and some change pounds at for a dry unit weight. We'll do that 4 or 5 times, and you get the program that we've got that plots all this up, draws this curve in for us now. But what you do is you put a best fit curve through all of the points. This just happens to be is that the reason I'm using this one is this is a good example of it just so happened we happened to hit one of the points at the maximum dry unit weight. That doesn't happen all the time. That rarely happens. But typically what you're going to see is this curve that goes through the points, and then you'll have, based on that curve, you'll pick off what your maximum dry unit weight is. And in this case, that dry unit weight was about 92.3 pounds. So in other words, we would just take a straight line from this high point of the curve, draw it over. That's our maximum dry unit weight. And the corresponding moisture content that's down here, that is our optimum moisture content. Now, when I'm saying optimum, and I'm going to get back to where we're talking about expansive soils, the optimum moisture content is not the content at which the soil stops swelling. The optimum moisture content means the content at which that soil is at its highest density. So in other words, what happens is as we start adding more moisture above that optimum moisture content, that optimum content, our dry unit weight starts to decrease. Okay. Can I get you to go to the next slide? Okay. Again, this is just talking about what our maximum dry unit weight is right here. Optimum moisture content is going to be down here, and that's nothing more than picking the high point of the curve, drawing a straight line over to the left onto the y-axis, picking that corresponding value, and then going straight down from that high point on the curve to the moisture content that we see along the x-axis.
So your best density for that soil is that combination?
That's correct.
With that much compactive effort.
Yeah.
Like I said, that would be like between a standard and a modified proctor. If you had the same material from a standard proctor and a modified proctor, you could have 5 to 6% more compaction on a modified proctor of the same material, because you're putting more force into it, which will raise the density of it up, and it will make the optimum moisture.
Yeah. If this was, let's just say this is a this is a standard proctor curve. If this was a modified proctor curve, what you would see is that the curve would start over here, come up, and come back down. So in other words, right.
Steeper.
Yeah. Well, it would be steeper. What you're going to end up with is you're going to end up with a higher dry unit weight and a lower optimum moisture content, because you're putting more force in to compact that soil. Okay. And then next slide.
But it still could be expansive.
It could still be expansive, and that's what.
Change the expansive property.
No, but that's what. But we can mitigate that expansion, and that's what we're going to talk about here. Is okay. So how do we decide what that level of compaction and moisture content are? An engineered fill is based on whatever our desired outcome is. You know, if we're going to be putting a shallow foundation on top of this, we want to make sure that it is stiff enough, dense enough to be able to support the load without it settling too much. If this is going to be a floor slab, we want to make sure that in some cases that material is compressible just enough to be able to handle the wheel loads that are going to be going across it. With sand and gravel, we want to avoid excessive settlement. With clays in this area, we want to avoid both heave and settlement. So the specified level of compaction, it's really based on experience. There's nothing out there in any textbook that says, hey, for a clay, it has to be this, or for a sand, it has to be this. It's pretty much all, the level of required compaction is all based on experience, and it's based even more on local experience and for the different materials that are being used. Well, in this area, for like granular materials such as a sand and gravel or clay mix, you're typically going to want to put 95% of your maximum dry unit weight. So could you go back to that last slide? And what I mean by that is, if this is our maximum dry unit weight, which, you know, let's say that's 92 pounds, then we want to be at 95% or better or higher when we're taking our field density test on that. So that's probably going to be 95% times 92. That's probably going to 87. You want to see 87 pounds per cubic foot on your dry weight when you're doing the test. So could I get you to go back to that other slide? Thank you. For clays, you're typically going to see between 93 and 98%. You don't want to, what happens is if you start getting above 98%, you're not going to have enough moisture in there to do two things. One is hold the clay together, so you're going to be able to support the loads that are going to be applied to it, and it's going to be drier. And so when it's drier, that's when it has a tendency to heave more. So when you're dealing with expansive soils, you want to think more water, the better, but not just a ton of water, because then you're not going to be able to compact it. You're not going to be able to it's not going to be able to hold up that foundation load that's applied to it. So there's kind of a fine line.
To moisture conditioning.
That's right.
You just said something that predicted my logical thought process.
Okay.
When clays are drier,
Mhm.
that's when they heat.
Correct.
My theory was if it got more moisture, it was expanding. That's not true.
It is. Well, it is.
Starts out dry,
If-
when you add
yeah.
water, it heats.
Okay.
Yeah.
When it rains.
And so when we do when I as an engineer are specifying moisture conditioning, what I'm trying to do is get that water in there before we put a foundation or a floor slab on top of it.
Okay.
So that the potential or its desire to take on more water is greatly decreased, because water's going to get moisture is going to accumulate under the slab. There's nothing we can do to stop that 100%.
But it doesn't typically dry completely out.
That's correct.
When we did the runways, we had to inject them, just bowl,
Yep.
and then cover them babies up.
Yep.
Just had to hooch them out.
Get them out. And you had a question, sir?
I was talking about my home foundation. I sat on clay.
Yeah. And it's going up and down.
Oh, yeah. I get seasick sitting in the living
And the thing about clay is, it will only move when there's a difference of moisture. So if the moisture stay consistent the same, you won't have any movement, because it's satisfied and it's not moving. As it dries out, it will shrink. As it gets wetter, it will swell. So what we try to do is try to get it pre-swelled and cap it with your building, and that's gonna slow down or mitigate any movement, because water can't evaporate through the slab.
That's why you're supposed to run your sprinklers every so often at your house.
Around the edges,
Yeah,
because,
well done.
because you'll see your movement of your house foundation, your monolithic waffle slab.
Yeah.
You'll get movement on the outside edges first, and it will slowly work its way in.
Yeah.
Roots and everything can get up underneath there and start drawing moisture out.
I was on a couple of jobs, the PVR, the potential vertical
Rise, yeah.
was like 9 inches, and we were moisture conditioning down to 20 feet.
Sal?
Dig a pit, start spraying water and mixing it, and putting it back in lifts.
That was a sound, right?
Yeah, yeah, that was the sound and out the column.
Runway was
Yeah, they call it a
26 or 28 inches.
Midlothian Google was 9 inch.
Yeah, that was that bottom lane.
I do have a question on that. When I'm doing that, I don't even have a place left to write here.
Here we go.
When you're looking at a slab on a grade beam, it literally had us putting 12-inch void boxes or carton forms underneath the grade beam, sitting on piers.
Uh-oh.
Because of the rise in the ground, they didn't want it pushing up on the structure of the grade beam.
Mm-hmm.
So I can see how that wouldn't push up on the structure, and up here we've got our steel columns and stuff. But right here next to it, inside the building, you know, maybe we have a couple of feet of select fill or whatever. What's really stopping all that? If you're expecting
Nothing.
12 inches right here and you step in 3 feet inside the building.
Well, let me, I'll put it to you this way. As an engineer,
Good question.
a very good question, all right? Well, let me ask you this. Was this grade beam and everything, was this all structurally connected?
Yeah, your grade beam and your slab, you know, you have your dowels tying them together.
Okay.
Then you've got your anchor bolts right there above your piers
Yeah.
or on a pile last year.
I don't know if that was a recent deal, to be honest with
Are
you.
you talking the rock?
No, that's on several jobs.
Well,
This-
that's what we did on the rock.
Yeah, this was the old, this was the old style foundation. When I first got into this 30 years ago, that was what everybody was trying to use around here. And what happens is what happened exactly is what you said, is that, okay, we've got a void space right here.
Well, I didn't mean
No,
to
he's
draw.
talking about the void space.
Oh,
here.
void
This is-
space.
this is
Oh,
the
okay, I'm
terminal
sorry.
grade
That,
beam.
that's the slab that
That's a
turns
lifting
down.
slab.
The
Yeah.
grade beam's 8 inches below it.
Yeah,
4-inch slab.
but there's nothing. So in other words, what I've seen before, like on some of the older style buildings, is yeah, that gets pushed up. The piers stay in place,
Yeah,
but this gets pushed up.
so I'm in there framing walls.
And that's getting pushed up from everything from the inside?
I'm inside there framing walls, we're putting a slip track, and we're cutting our sheetrock down to where the slab heaving up and down doesn't bow all the studs and break them out. But really, it's only designed for about 1 inch of movement.
Right.
And here it's documented, I could expect up to 9 inches of movement.
Sure.
Right.
I got a 12-inch carton for them, I'm going.
The rule, yeah, the rule in this industry is when you're doing void spaces, you always put the void box in for what you anticipate your maximum amount of heave is going to
Probably
be.
plus some.
Yeah, and I mean, you put, well, void boxes only come in like 4, 6, 8, 10, 12, and then you just stack them after that,
stacking
yeah.
them on there.
And so you're going to specify, you know, you're going to add maybe a couple inches to it, just to be,
Yeah.
you don't want to give an oddball
Like I
number
said,
on your
the
void.
PVR was 9, we're putting in 12.
Yeah, and so you've got a factor of safety on
But
that.
On where I had these 12, we moisture conditioned everything under here.
Right.
I've done so many jobs where it's just a void box, no moisture conditioning, maybe a couple of foot of select fill.
Well, the only way that that's going to work long term is if this is a floating floor slab.
There you go.
That's the only way that that is going to work. Most of your, I would say, just about all of your retail construction, your local, you know, insurance office, doctor offices type, that's the way this has worked. So in other words, your exterior walls and the actual structure of the building is supported on piers, and that is separated from the soil. But because of cost, everybody's willing to accept that, yeah, I'll get a little bit of, I'm willing to take the risk for the reward of having to spend less money in construction.
Usually that's about a half inch or less is what they go for.
Yeah, is you'll have a floating floor slab in here that'll go up and down. Like the Bell helicopter plant out in Fort Worth, right there off of Fossil Creek. I can't remember, right there where, yeah, that's all on a floating floor slab.
Yeah, I just can't
Yeah.
imagine if that moved up 9 inches, I gotta have a 12-inch carton form.
If-
What would that inside slab
Well,
look
if,
like?
If you didn't treat it, it could move
That
that
much.
much, but if you moisture condition.
Which we did on
Now
some.
you're
Walk
bringing
in-
the PVR down to 1
go
inch.
go over to Grapevine Mills Mall and walk into the Saks Fifth Avenue store from the outside, and you'll see exactly what that looks like.
Yeah, like I said, we did do the moisture conditioning here, we did mitigate it, but I've still got the 12-inch carton form, they didn't
Yeah.
change it to 4 inches.
Well, but again, here's the thing is that's a practice that's done in the geotechnical community, to where if hey something got missed, at least the structure, which
Yeah,
is the
the
most
structure's
expensive,
protected.
yeah, the structure's protected, but that only really works is if you've got a floating floor slab where you can come in and grind it or pull it up and replace it relatively easy,
Or you do a structural slab.
or you do a structural
Yeah,
slab.
Carton forms under all of it.
Yep.
Yeah, we've done that.
Yeah.
I did that-
experienced all carton format too.
I did
Yeah.
that at Halliburton, the whole addition was all structural slab with carton form.
Yeah. And then I'll finish up, and I think I'm done after this, is the flexible base. You're usually going to see that between 95 and 100% of your compaction, of whatever your maximum dry unit weight is. Now, I will tell you this. It is possible to get more than 100% compaction. And the reason for that is because we're basing that on whatever that maximum dry unit weight is that we determined in the lab. You can get a much bigger piece of equipment out in the field that is going to put more compactive effort on that soil than what we were able to do in the lab. And so because of that, you get a much denser compacted soil in the field. And so therefore, when you figure out what that percent compaction is, you can have more than 100% based on our laboratory dry unit weight.
So we're just surpassing your scale.
That's correct.
I just figured the Proctor was off a little bit when I had 103% compaction.
No, you can, no, yeah, but you can,
You're
but,
compacting it with something more
It's
than
like,
what. 'cause
put in
we're only allowed
110%
so much
effort.
Yeah.
effort. What?
yeah, well, it would be, it would be if I got a Bobcat and I rolled over some ground and said, okay, that's my standard right there, versus if I got a D12 out there and rolled over that same patch of earth.
So, dirt-wise, select fill, I've just got it memorized as for select fills, non-organics with a PI between 5 and 15. Is there more to it than just not having roots and topsoil?
Yeah, you want either like a sandy clay or a clay sand type soil, and what we typically specify is a liquid limit of no more than 40, and sometimes we'll say between 30 and 40% has to pass the number 200 sieve, because what that does is with the select fill
It
is
does get more complicated.
it does get more complicated than that. And the issue that everybody's running into is all of your close by sources of select fill are pretty much getting exhausted. So being able to find a good, and when I grew up, it was pretty much, oh yeah, select fill is 5 to 15, and it's 30% has to be no more than 30% clay. There you go. Now it's getting much harder to find that. And I, as an engineer, I've relaxed that spec some to where I'm telling my clients, hey, if you're going to use a select fill, it can be have a PI of between 5 and 20. It can have up to 40% clay. But what we're telling them to do is put it in a little bit wetter than what you typically would.
I like the more clay in it. When you're going to be
Trenching
earth
for,
forming,
yeah.
trenching, ditching, it's a lot easier to deal with.
Select fill just doesn't exist in its full form anymore.
Well,
All the pits are being exhausted.
It's
Yeah.
all being exhausted from people building on it or excavating it out
Yeah.
and putting it in buildings. There's
All-
not a lot of local goods
Yeah, a lot of your select fill pits are along the rivers, the old river channels, and all that area is either getting developed or it's already getting mined out.
Everything we excavated from the oil well was just beautiful, man. I just wanted to, we had so many people coming by, what are you doing with that dirt? And Bill employees, what you gonna do with that dirt?
Bill
Yeah.
does have a lot of good.
Hell, I wanted it for a low spot in my backyard, man. That shit was good.
Yeah.
Everything I've built in Oklahoma, they basically had select fill was the ground.
The whole, just about all of Oklahoma except for the Panhandle is select fill.
Yeah, I mean, everywhere I went. it
I'm
basically
serious.
was select fill.
Well, and
I've
you
done
get,
piers and great beams with no carton forms.
yeah, and you get down around Tyler, Palestine, Athens, that area. I mean, you'll have some clays out there, but you've also got a lot of naturally occurring sandy clays and clay sands that are great select fills. It just costs way too much to transport all that material up here.
Trucking's what,
Yeah.
if you're a dirt, yeah, if you're an excavation company, how far you have to truck stuff. They got is the good whole stuff game. up in Ohio, but.
That's why you're seeing a lot of people using recycled concrete now. Same property, same, I guess, characteristics, but it's locally.
It's locally sourced. Yeah.
That's why lots of times we'll try to get that approved.
Yeah. Or a lime treated material, same,
Yeah.
I mean, you've got options.
Then I've got one more slide, and I'll let Bobby take over. Okay, so we talked about how do we determine what the compaction level is or what our dry density is going to be. Why do we determine what the moisture content is going to be? That specified moisture content also depends on what our desired outcome is. If we are in a material that, hey, we're wanting this to be stout enough to be able to support this load, we're going to have a tendency to give a little bit lower moisture content. If it is an expansive material and we're doing a moisture conditioning, I'm going to tell you, hey, we got to put as much water in there as we can within reason. Okay? For sand and gravels, with maybe a little bit of clay, so we've got some stickiness or some cohesion to it, we're usually going to specify in between plus or minus 2 or 3 percentage points of the optimal moisture content. So in other words, could you go back to one of those slides that has the curve right here? Right. This is our optimal moisture content, right down to the high point of the curve. I'm going to tell you for a clay sand or a clay gravel, 2 to 3 percentage points on either side of that optimal moisture content. Because we want it to be sticky enough to where it's going to compact very well, but I don't want it to be too dry where it's going to fall apart as soon as you put a load on it. And I don't want it to be too wet because it just becomes too soft and you're not able to compact it. Okay, so could you go back to that last slide? Thank you. All right. Now, for clays, that depends exactly on how expansive that material is. For a very expansive material, say like you're dealing in Las Colinas, Carrollton, Frisco, west side of Prosper and Salina, that area up in through there, I'm going to tell you minimum of 4 percentage points above optimum. And the reason for that is based on experience and it's based on field tests that we've done where we've picked up samples of compacted material, brought it back to lab, run a swell test on it, and we know what the moisture content is that we started that test at. So if we know, that way we can gauge if we've got enough water in the soil to where we're going to mitigate that potential for heave. So +4, which is above the optimal moisture content. Sometimes I'm going to put an upper limit on it. Sometimes I'm not, because you're not going to be able, if you put too much water on it, you're not going to be able to get the required amount of compaction. So, yeah, because it's going to get too soft and it's just going to get pushed out, as the tracks are running across it. Okay, for moderately to non-expansive clays, usually between 0 and +2% of your optimal moisture is good enough. You really don't want to put in clays dry. In other words, you don't want to put them in below the optimal moisture content because they have a tendency to not hold together. They'll have a tendency to crack, and then you start having issues with settlement, and you'll start having issues with heave. So you always want to put your clays in at or above, as a minimum, at or above whatever your optimal moisture content is.
I've got a vast amount of experience. I've been in this business for 43 years in this area. I basically started a year out of high school. So it's something that I started out as a technician, kind of worked my way through, just really like the, I guess the interaction with construction materials testing, something I just kind of gravitated to, and I thought, well, you know, let's make a career out of this. But a lot of this, you know, my presentation is going to be components of concrete. I don't know how versed you are with, you know, how concrete's made, how it's proportioned, some of the effects of different things that go with it. But just basically, concrete is a hardened substance. It's a man-made material that it can vary. You know, if you order 4,000 PSI, 1-inch aggregate, you know, mixed design 9468 from a supplier, is every truck going to be delivered the same? No. It's going to be similar to the same, but it's not going to be exactly the same on every truck because it's batching, it's got computerized batching, and it goes off of weights, and there's a little bit of variance. It should be, you know, plus or minus 1%, you know, for the industry standard of, you know, of all the trucks that are produced that day from that mix, but it's going to vary. Plus, also, once it gets to the job site, depending on what you guys do or your subcontractors do with it, will affect the actual the outcome of how it's going to perform in the field. So, if we can kind of scroll down just a little bit. So, what is concrete? Concrete is water, sand, which would be fine aggregate, stone, which would be the coarse aggregate, and then the cements. And the cements can be, you know, type 1, type 2 Portland cement. Right now, type 1, type 2 is really hard to find around here. You're going to basically be buying type 1L cement because that's environmentally what everybody's pushing to because it has a smaller carbon footprint. Bad thing about it is it's still relatively new to this area. And so a lot of the suppliers, and I talk to them all the time, they have erratic breaks because it's kind of a learning curve on the mixes and how much to use and their suppliers. And so, you know, they're dealing with different types of cements that they have to buy to produce these consistent mixes. We also have fly ash, which is a pozzolan, which is an admixture that they can add, which can substitute for some of the Portland cement. It's a little bit cheaper, and it has different characteristics. It'll make it set up a little slower. It'll be more consistent, but then you also have different things that you have to deal with as far as how much fly ash you're going to use and what it's going to do to the performance of that.
Is that a byproduct of burning coal?
It is.
And then what's the difference between type C and type F? A lot of the cities insist you use type C.
All the cities use type C, mainly because it's more consistent and it's more readily available here. You know, there's not a whole lot of coal being used up in this area, so they've got to truck it in from different parts of the country. So a lot of the municipalities, two, it's a little bit more inconsistent, and two, or one is that, and two is it's what they've always used. You know, yes, sir.
Can I also add about the difference? The main difference between the Class C and the Class F is the amount of carbon that's in there. And if you have too much carbon, it will consume the air additive that's in the concrete. And so even though you're dosing the concrete for your air, it'll basically react. It'll eat it up.
Yeah.
It'll consume it, so you end up with a lower air content.
Are you going to touch on air in concrete?
Yes, I will. Okay. And then there's also chemical admixtures, which nowadays that's a really big proponent of concrete. You know, back in the 80s, when I got into this, there was hardly any chemical admixtures being used in this area. You know, you'd have air, you'd have water setting type admixtures, and that was about it. You know, there was no such thing as a super plasticizer until the mid 80s. And when it came in, boy, everybody loved it. Wow, this is the greatest thing. You know, Gifford Hill was the first company around here that introduced super plasticizers. And I was working on a project up in Addison called the Madison. It's a office building, And Gifford Hill brought it out, and they said, hey, guys, this is the best thing since sliced bread. You can pour an 11-inch slump, and it's not going to hurt the strength. And so we made all kinds of mix designs and batches and trial mixes with this. And it had good results, but it was like anything else, kind of like the Type 1L cement. There was a learning curve with everybody using a new product. You know, everybody thought, wow, the wetter the better. But then you start using a concrete that's got 11-inch slump, you pour it into a mix, you hit it with a vibrator, and what's going to happen? All the rock is going to go down to the bottom, all the air and the sand and the water is going to come up top. You're going to have bleed water forever. So it was a fine-tuned thing that they had to do with these different types of products. Let's go to the next area here. So the ingredients of a concrete mixture. Again, you got coarse aggregate, you got water, you've got air, you've got fine aggregates, you've got your cements, and then your admixtures. If you scroll down, the actual proportions of a typical, say, 4,000 PSI concrete, 3,000 PSI concrete, 15% of that is going to be cementitious material, whether it's the Type 1L cement or it can be Type 1L with the fly ash or pozzolan. 20% of that is going to be water. 65% of that is going to be the aggregates. And of that aggregate, 27% of that is going to be sands, and 38% of that is going to be the coarse aggregates. So there's a lot more coarse aggregate than any other product in a well-blended concrete. Some concrete's a little bit more lean than others. If you're going to have to pump it, you've got to be real careful. It can't be too rocky. You know, so a lot of submittals that you get on a project, if you're going to be using a pumpable mix, there are certain things that you want to include in your mixes to make it more workability. You know, you don't want a really good high strength concrete that you can't pump, because now, you know, how are you going to place it?
Is it aggregate size grows the more the strength of the concrete?
Not necessarily. If you look at high strength concrete, and we have some producers here that can make really high strength concrete now. You know, typically, you know, what do you guys see? 3 to 5 to maybe 7,000 PSI on your projects. There's some producers around here that can go 15,000 PSI.
Yeah, I've fit over 15. I've fit up to 18, 19,000 on a 3,000 pound mix.
Yeah.
They didn't care about the strength. It was the density.
Correct.
It was because it's the cancer treatment machine stopping.
They want the heavyweight stuff,
Here
yes.
I'm looking at this 3,000 mix and my brakes come back. What the heck?
Yes.
It's the density they were looking for created that. They didn't need it for the strength.
Yeah, if you look at the high strength concrete, which is 8,000 PSI or greater, you don't have 1 inch aggregate. It's all 3/4 inch aggregate or maybe 1/2 inch aggregate, because you can really densify this, because the rock only has so much compressive strength before it shears or breaks. So the smaller you get with the right amount of blend of the matrix that's surrounding it, that's where you're going to get your high strength from. And when you look at the strength of a gravel versus a crushed stone, gravel is, you know, the rounded stone. It's a lot harder than the limestone around here, but the angularity of it, it doesn't interlock with itself. It's just kind of like ball bearings. And when it's pushed together, it will just tend to roll. Where aggregates with, you know, crushed limestone, which the limestone is not from around here. You know, the limestone that we have that you see like on drill piers or on any of your projects, that's the Austin chalk type limestone, and it's kind of punky. It's, you know, you can excavate it. You can't use that for concrete because it's not hard enough, not sound enough. You'd have to go to Bridgeport, to Chico, or down south, down toward, you know, Austin, San Antonio, to get the more crystalline limestones. A lot of limestones now are coming from Delisi up there in Oklahoma, because they can only mine so much in this area. So now they're going to different suppliers. Can we go to the next slide here?
Delisi's in my hometown.
Oh yeah? Okay.
Davis.
So these are the types of admixtures for concrete. Type A is a water reducing admixture. Water reducing admixtures are great if you want to improve the strength and the durability of concrete, because it lessens the demand of water that you would need in a mix to be able to use it, you know, workability wise.
That's basically the plasticizers.
Well, the plasticizers are going to be the high-range water reducers, which is the type G. So the normal water reducers, almost every concrete mix that you'll get will have a water reducer in it. One, it makes it easier for you guys, plus it makes it cheaper for them to produce it. But type B is a retarding admixture. You don't really use a lot of those in the wintertime around here. You use it in the summertime to give you more life. Because if you don't use it, it's going to set up a lot faster, and now you've got a truck, excuse me, that's set up and you can't use it. You got to send it back, and now you've got cold joints, and it can be a fiasco. A type C admixture is an accelerating admixture. We don't use a whole lot of that around here because you want to use that on cold days, but a lot of times those have salts in them, and a lot of suppliers or specifiers don't want you to use that type of admixture because it's going to make your rebar rust out a whole lot quicker.
So it will specify non-corrosive.
Correct, yes. Yeah, there are non-corrosive admixtures that you can use, or you can use certain types of rebar. You can use epoxy-coated rebar or fiberglass rebar with a lot of these accelerating admixtures, and it's not going to affect it at all. Type D admixture is your water reducing and retarding admixture. So it's a combination of AB. So, in the summertime, you want to reduce the amount of water so you can lower your water cement ratio. The higher the water cement ratio that you have, the weaker your concrete's going to be. If you can lower it down, it's going to make it more strong. It'll make it more brittle, but it will give you higher compressive strengths. The type E is the water reducing and accelerating admixtures, which they're hardly ever used around here. Type F, water reducing high range admixtures. So this is your plasticizers. Now you're getting into the fine high end stuff. Type G is the water reducing high range and retarding admixtures. You would use that in the summertime around here. And then type S, there's are just specific performance admixtures. There's shrinkage compensating admixtures, which will keep your concrete from shrinking as far as the size. Because concrete, whenever it dries and cures, it's going to get smaller and smaller up to a certain degree.
That would work best on an elevated deck where you're not cutting control points and you don't want the shrinkage cracks.
Or a freezer. A lot of people use those shrinkage compensating like in the floor of a freezer because they don't want it to shrink and develop cracks. There's also some admixtures, they're self-healing to where if they do have fine cracks that develop, it will actually activate with water and it will produce a paste and it will seal itself up. There's different type of admixtures that can make concrete less permeable because all concrete is permeable. So water will flow through it eventually. That's why on swimming pools, they do the shotcrete and everything, and then they have to come back and put a plaster layer to kind of seal that off because if not, your water is just going to sit there and just flow through it eventually. It's going to take a while. Bentonite is a naturally occurring material.
Correct.
And we do have some in these soils around here, not a whole lot, but it's an expansive type soil to where when it's activated with moisture, it will swell and make it waterproof.
It's not a structural application in any.
No, it's very soft.
Was used to seal the
Waterproofing, yeah.
Waterproofing, yes. Yeah, so the Volclay panels, same type of thing. It's little thin sheets of the bentonite that they would adhere to these concrete structures, and then when water activated it, it would swell and seal itself off on the outside.
only if it's compacted.
Only if it's compacted, correct. So let me ask you a question. Do field sampled concrete specimens represent the actual in-place compressive strength of your concrete? So if we make concrete samples, we take them out in the field, we cure them, is that supposed to represent the strength of your structure?
To a degree it is.
To a degree. It should be similar, but it's not apples to apples because we cure it differently. And this came about, years ago, OSHA had a big thing of field cured samples. So they want to know, okay, the samples that the testing lab is making, we want it to be representative of what's out in the field. So what they would do is they would grab their samples, they would sit it right beside the structure that they set, and it would stay there until you're ready to test it. They'd stay out in the field, they'd stockpile them, they'd cure them the same way. If they sprayed curing compound on this slab, well, they'd come over here and spray the cylinders with the same thing because they wanted apples to apples. Still wasn't apples to apples because our samples are so small, they're more susceptible to the environments around it.
Your ground temperature
Correct.
is more
Sure,
stable.
sure. And so a lot of concrete producers came up and said, hey, you know, why am I delivering a 3,000 PSI rated concrete, but then it goes out in the field and this thing sits out in the sun for 120 days. It's, you know, it has no moisture to it. But then when your cylinders may break good because, you know, we grab those after 24 hours, we take them to the lab, we strip them, we put them in a environment that's perfect for it. 73 degrees, plus or minus 3 degrees at 100% humidity. That is, concrete, over the years, they said this is the best, you know, way to cure concrete. But then out in the field, it's not the same. So now you're comparing apples to oranges here. So this is a little slide that talks about just the curing temperatures. So if you look at this, if you had cylinders that were cast in the field, kept in a thermostatically controlled box at 60 to 80 degrees for the first 24 hours, then took to the lab, stripped, put in the curing room for 28 days. This is 100% moist cured. At 28 days, you're going to hit 100% of what it should be. Now, if you have a cylinder that you make out in the field and then you strip it and you let it sit out in the field the entire time at 28 days, your strength is only going to be maybe 60% of what that is, which is huge. You know, if you're looking at a 4,000 PSI, 60% of 4,000 PSI, you're lucky to get 2,200 PSI out of it. So, you know, after this is, it's cured normally, but then after 3 days, it's left out in the air. It gets a little bit stronger. And then after 7 days of good curing, then it's left out in the air. It gets a little bit better. But these are the effects that your in-place concrete has when it's exposed just to the air. This is just the moisture portion of it. So let's go down here a little bit more to the. Okay. So this is the difference in temperature. So like I said, you've poured your slab on grade. It's exposed, you know, you poured it in August. It's 105 degrees, okay? But actually, on a cool day, that's in the shade. So if you run an actual temperature of concrete that's being exposed to direct sunlight, you're talking 155, 160 degrees. It gets hot. And so in this, I think this is days. Can you scroll down? Okay. Oh, it doesn't have, I'm sorry. So at 28 days for strength that's 40 degrees Celsius, which is 105 degrees, your strength is going to be down here. But then if you get it at 70 degrees, your strength is going to be up here because it has gained strength through a longer, slower process. Now, if you need a quick 3-day break, you're going to get a higher 3-day break because this is way down here. You may be way up here because it's accelerated very quickly, but then over time, you're going to have a lot less ultimate strength out of something that's cured quickly rather than something that's cured nice and gradual. That's why you'll see TxDOT, they wrap all their columns. They put curing blankets around everything and they usually let it moist cure for 7 days before they even touch it. In a practical world, commercial, it's almost impossible to do that. Y'all have got schedules. You've got to, you know, you drill piers on it one day. The next day, you're excavating around it for pier caps. I mean, your owner's wanting you to go, 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 go. But that's what TxDOT does. So, you know, a lot of the roadway type stuff, they have that built into their schedule. But
Is
Correct. Yes, it does. Yeah. So what happens in this situation, if you cure it at a higher temperature, did I? Okay. Okay. That's what's happening. Okay. So if you cure it at a higher temperature, you're going to get higher early strength, but it's going to be a lot more brittle. So you need to be real careful. Which can cause early cracking. You really need to get on the saw joints like as soon as you can, not the next day. Usually later on that day, you need to schedule your saw guys out there.
That happens.
Yes.
A lot of times we use the wet cure blankets that won't necessarily help with the heat, but it'll help keep the moisture in.
Correct. You spray your con film on there as quick as you can to help keep that moisture in there. Because what happens in concrete, the way you get the strength is that when that cement and that water starts to hydrate and it starts with the chemical reaction, it starts creating crystals inside of itself. And the more crystals and the longer the crystals that you have, the more interaction you get, the higher the strength that you get. But if you cure it very quickly, those crystals are going to grow real fast and then just stop. So, you're not going to get hardly any residual strength. If you notice, see how flat this came very quickly? Yeah. So you're not going to get ultimate strength gain. Now, if you add a fly ash to this, it will start mimicking this at a higher strength as well, because it's actually slowing down the heat of hydration in that chemical reaction with the cement and the water particles.
So this is kind of a hot weather concreting discussion on this.
Correct.
Are you going to get into adding ice to the mix, or what about nitrogen that we don't know that much about?
I can. I didn't have it in the slide, but a lot of people, summertime, you'll see a spec 95 degrees, 50 to 95 degrees for fresh concrete temperature in the field. Well, in August, good luck.
Well, the rock they're loading at the plant set out in the sun.
It's been
all day
baking.
The day before,
Yes.
3 a.m., it's still 100 degrees.
So that's why if you go to a batch plant a lot of times in the summertime, you'll see those sprinklers going, because they're trying to cool that aggregate down, because they're screwed because they've got this hot aggregate and they've got to get it down to where you can use it. So, the sand, same way. You just don't want to have a whole lot of water on your rock and your sand, because it's going to start washing the fines out of it. Then you're going to have inconsistency. You'll have one truck that's, really rocky mix. The other one's a really sandy mix, and it's going to be really hard for finishers and everything else.
What about nitrogen? Because I hear about it, but I've never used it.
Hardly anybody use it because it's very expensive.
Okay.
It's a good product. We went out, and I was on the ACI board 10 years ago when it really started to really come into the DFW market, and they used that. We went out there and watched them batch it and everything, and it's a very long process.
Is it more for mass concreting that you'd bother using it?
It's both. Mass concrete or specialized, specialty, high-end stuff, because it's very expensive. It's a mess, because when they start injecting this liquid nitrogen into the concrete, it's kind of like dry ice, and you're going to start getting this fog come out of it, and it's going to go forever.
Like dry ice?
Yes, and it gets really slippery when you start walking around it, so it can be kind of a safety hazard as well.
Okay.
So a lot of people don't use it. They'll spend the extra money for chilled water or ice, depending on how much ice to use. But a lot of the admixtures, if they use a medium range to high range water reducer, you can go up to 100 degrees, and the specifiers will say that you can. And so that helps in the summertime around here. All right, can we scroll down? So reduce concreting. The high temperatures found during the hot weather concreting accelerate the cement hydration process, which may seem advantageous as the concrete gains strength quickly. However, the temperatures are too high and the reaction goes away very quickly. The final 28-day strength will be lower than expected. This can be very frustrating as you think everything is going according to plan until you get the low compressive strength of the 28-day test. So again, it's what you need it for. Do you need a high strength? I need to get on. I got to have traffic on this thing in 3 days. You know, a lot of times, you know, in the summertime, that's a really good benefit. Wintertime, you may need an accelerator, or you may need hot water to elevate that moisture a little bit to kind of get that heat of hydration of that cement going to where it will set up a lot faster. Setting times for concrete at various temperatures. At 40 degrees Fahrenheit, it's going to take about 14 hours to set up. You know, in the wintertime, we have some of those days. Versus in August, when it's 100 degrees, you got about an hour and a half. And that's best case scenario. A lot of times, it's even less than that.
When you're waiting to finish a slab and it's 40, 50 degrees, you need the accelerator. You're gonna be there all night.
You do. And that's why, you know, a lot of the high-rise stuff, you'll see them put blankets. They'll put heaters up underneath there to heat that concrete up as well. It's very costly, but it can kind of keep a project on schedule. They'll not only heat it up from the outside, they'll put barriers around the outside on the top portion of it to keep that cold wind from blowing it, to cooling it down. Because you want concrete to set up at the same rate. You don't want the bottom to start setting up and the top having a lot of bleed water and really cold, maybe frost. That's when you start having some really bad issues with concrete. Can concrete freeze?
Yes.
Sure can. All right, can you scroll down a little bit? So when you have concrete and it's not just a freezing temperature or freezing water, but all concrete has moisture in it at all times. Whether it's in the summertime, it's still got a little bit of moisture in it. Most of it's probably evaporated out. But it has moisture at all times. So what happens is when concrete falls below freezing, the water particles inside the concrete, what happens when you put, it expands. So water is going to expand when it freezes. So if you've got trapped moisture inside of a concrete slab or a column or elevated beam, and it freezes, that water is going to expand and it's going to micro crack that concrete. And over time, through freeze-thaw cycles, it's going to crack it and then it's going to thaw out. Then it's going to crack it and it's going to thaw out. But every time it cracks it, them cracks get longer and longer and longer, and now you've got more areas for moisture to get down in there because now you've got all these micro cracks on the surface. So concrete companies have come up with admixtures for air, and it's a liquid that they put in there, and usually the ideal portion around here is 3 to 6% because we don't have a whole lot of freeze-thaw cycles here. So that's a good percentage of anything that's exposed to any outside environment. You'll want to put air in there just for durability. Anything interior, you don't need it because, you know, unless you're going to have an area like a freezer slab. But you're not worried about the freezer slab being a freeze-thaw area because it's going to be frozen and stay frozen. And so it's going to do its thing and then just sit there forever. But if it's going to be exposed to the freezing and the thawing and the freezing and the thawing, that's what deteriorates this concrete. So if you scroll down a little bit.
You're gonna have air in your mix.
Correct.
Exterior concrete.
So this is kind of a detail of what a concrete matrix could look like with air entrainment in it. The air entrainment, the bubbles that you see, you cannot see them with your eye. They're microscopic and they're very tiny. The only kind you can see that is through a microscope. And they're so small that there's so many of them. This is a larger version of that. So this is an air bubble that's in hardened concrete because it makes just these little microscopic bubbles, and whenever it sets up, now you've got this little round void. And so the premise of this is for this moisture that all these little dots are basically moisture particles. Whenever it freezes, what the design is as it freezes, it's going to squirt water into here. And it needs a relief, like a reservoir. And so that's why it's not going to micro crack this. And really, they said that during the freezing of concrete, the water moves only about 1/8 of an inch. So you've got to have a lot of little bubbles in there that are at least, or no more than 1/8 of an inch apart to give yourself some reservoirs. If not, you're gonna, you don't have enough air in there. And so when it freezes, it's gonna pop water through into these bubbles and fills this up, and now it's got a little bit of play area, and then when it thaws back out, it'll seep back into the concrete. And then when it freezes, now it's already got capillaries to where it'll keep filling in there, coming out, filling in there, coming out, and it's not gonna deteriorate the concrete like you would normally see. Can we scroll down? So this is the average strength gain of properly cured concrete. Some people said, well, how quick does concrete, usually cure? Well, at 28 days, it's going to be around 99% of what the ultimate strength is going to be. Usually at 1 day, depending on the mix, depending on the temperature, you're going to get around 16% of what it's going to be at the 28-day strength.
I'm used to that 7 day being 75%. It seems to hold true. I have it in my head, but you've got 60.
Well, in warmer weather, you're going to see the 70 to 75%. This is just the average that ACI has, and
When I see my 7 day break,
and you're not at 70,
75%,
it's kind of scary.
it's always going to come out right.
Correct.
On the old.
Yeah. Now in the summertime, depending on how the cylinders were cured, if they've been sitting out there on the job site for 2 or 3 days, it's going to be higher at 7, but then lower at 28. So you have to make sure, your cylinders are being picked up at a timely manner. They're being cured correctly. But again, the cylinders that we make, again, don't represent, and this is a big argument with structural engineers and suppliers, because the suppliers have went to bat for themselves with ACI and said, those cylinders should represent what we're producing, not what this guy's doing out there on the job site, because I have zero control over it. And so they've kind of curtailed the specs to be perfect conditions, basically. But then out in the field, if you have a low break on like some cylinders that I made, and you say, hey, let's verify, do we really have a low break or not? Come out and do cores. Well, if I do cores, I'm not comparing apples to apples. I'm comparing the pristine stuff that still didn't make it to maybe something out in the field that may be either a lot higher or a lot lower, depending on the atmosphere that it was surrounded.
Probably already cured an additional 30 days by the time this is happening.
Correct. Plus mass concrete will kind of protect itself. Our cylinders are very vulnerable, where if you pour a 12-inch thick concrete slab, that concrete is going to be a lot more protected from any outside environment than what our cylinders are.
Yeah, sometimes the guy who picked them up drops them.
That happens. Hopefully not by us.
Sometimes they get moved around in the field.
Sometimes we'll go by the next day to pick up our cylinders, and somebody's used them as a picnic bench, and they've been knocked over. And
Next to a sprinkler.
yes,
It's a big deal in the field that we talk about where to put them to protect them.
correct. So on most of your projects, do you have curing boxes? Okay.
Not since the 80s.
Okay. It's probably, this is something that the suppliers are really pushing. And so they're saying, we shouldn't be held to this standard if y'all are just basically leaving them out there vulnerable, and then you get low breaks, and then you want me to pay for it.
When it's super cold, we'll put our same insulating blankets over
Correct.
them that we did the slab.
Yes.
If it's super hot, they might go in the job trailer.
Yep. So what we recommend is maybe just an insulated concrete box with with a lid that we can adjust. So in the wintertime, you want to seal it off. That way the heat of the cylinders kind of protects themselves inside this
When it
iglue
started,
cooler.
We would dig a hole.
Correct.
Plywood cover.
Yes. But then in summertime, you don't want to put that lid on it or seal it. You want to open that up till air can go into it. If not, you're going to cook those cylinders.
Yeah, well, the ground temperature helps.
Sure. Oh, yeah.
But usually you guys are pretty on top of it, and you're out there the next day. I know I've never.
Sure. We try.
You guys are usually there the next day.
Sure.
So,
And there's some projects where the supplier says, we only guarantee this strength if these cylinders are kept at 60 to 80 degrees for the first 24 hours. Yes, sir.
Could you just comment on how important it is to cure now that they're using the 1L cements?
I'm sorry?
Could you just comment on how important it is to field cure now that they're using the 1L cement?
Yeah, well, these brakes are coming up low now.
Very erratic, because like I said, it's something that the suppliers are still scratching their head, they're still dealing with it. But as far as field curing those type 1L cements, which I guarantee every one of your projects are using type 1L cement.
We got so used to the brakes always coming in so high, and then all of a sudden here lately, like I said, the last 2 years,
Correct.
all of a sudden, sometimes every once in a while, just right on the line.
Well, what happened there for a long time when they started introducing the type 1L cement, since there was such a variability, a lot of suppliers said, I'm going to cover my butt and I'm going to raise the amount of cement in this mix. That way, if it does fall low, I'm still okay, which kind of defeats its purpose with the carbon footprint, because now you're using more of a product that has a less of an environmental impact. So it's still the same environmental impact, but now it's costing more.
I like the safety factor.
Sure.
I think in our two big foundations, both had that same issue, the brakes broke low initially, right?
Well, they all met specifications,
But it took long.
yeah.
Now, on a project, when the concrete cylinders break low, does that mean that it needs to be ripped out?
No, it means we're gonna do a core test on the inside.
Correct. Well,
Have a discussion.
also,
We don't talk about it.
we're going to discuss this. No, ACI and ASTM understand every now and then you're going to have a hiccup. So you are allowed to have low strength concrete and still be considered structurally acceptable, because the way the ACI 318 building code says is, if you have a set of cylinders and it breaks low, as long as the average of those cylinders are 85% of the required strength and not one of them are 75%, in a 3-day running average, in a 3-day or a 3-set average, it's still considered acceptable. And that's ACI 318.
And the lawyers agree with that?
They do.
So that's an average of all 4 of your set of cylinders for that.
Just like the 20, if it's specified 3,000 at 28, it's the 28-day breaks.
So if we have 2 at 28 and 1 in whole, we could use those 3 as an average?
Well, typically on 4x8 cylinders, you have to make 3 cylinders, because ASTM you could only make 6x12 cylinders. Back when I started, you could not make a 4x8 cylinder for
No,
concrete.
we usually make 4 cylinders, 1 7, 2 28, 1 whole.
Not for 4x8s, you should not. You should make 5, because it's 1 7, 3 28s, and a hold.
There you go.
And so you can average the 3 28-day breaks, see if they come up to 3,000 PSI.
There you go.
If they do not, then you can look at the 3-test running average. So in other words, if you made 3 or 10 sets that day,
There you go.
as long as these 3 average this, and then drop this one and let's go to this 3, and then drop this one, let's go to this 3. As long as none of them fall below 75, or no, that's below 85%, you're good. Same way with cores. If we go out there at a 4,000 PSI required and we take 3 cores, because you should have an average of 3 cores. As long as the average of those 3 cores are 85% of the required strength and none of them are less than 75, you're good. Per the building code. I'm sorry?
1 below 75 is still.
Yeah, if you get 1 below 75, you're out. You can't use that rule.
Okay.
As long as
Okay.
something's below 75%.
Yep.
All 3 average
Is at least 85%.
Yes. And so the fresh concrete, it's the 3-day run, or the 3-test running average. The cores is the 75 and 85% rule.
According to ASTM.
That's ACI 318 in the building code. Now that's considered building code, so you're thinking this is just for the building only. A lot of civil engineers still adopt that for all the civil work as well. Some of them don't. They say, sorry, the building code does not apply. I want you to take it out. It happens.
Yep. It comes out because it's got cracks.
Sure. Well, there's 2 types of concrete, and I didn't say this out loud, and you're probably recording me saying this. There's 2 types of concrete: crack concrete and concrete that will crack.
Yeah.
Okay? Because one, it's it's gonna crack. You know, it shrinks, it moves, it's brittle. You know, the flexural strength of concrete is a lot less than the compressive strength of concrete. So in tensile strength, you get about 10% of the compressive strength. So if you have 4,000 PSI compressive strength, you're only about 400 PSI in tensile strength.
I should have said visible or bad looking cracks.
Correct. Well, according to the city of Dallas, and we had a meeting with them, you know, with all the 311T stuff, they said we don't buy cracked concrete.
I've walked down the
I'm
street
thinking,
marking out.
yeah, you do. You do it every day. But you want to control where the cracks are. You know, saw joints, expansion joints, control joints. Do I have any more? Okay. So this is just some of the, you know, and this is just kind of round out my thing. You know, this is just some of the typical duties that, you know, a firm like us would do for, you know, construction materials testing in the field. We sample fresh concrete. We observe rebar placement. Observe drill piers or piles, whether they're straight shaft piers, belled under ream piers. Anybody deal with any helical piers?
Oh, yeah, we all.
Okay. That's becoming a very viable option.
We've done it a lot.
Yes. Slurry piers, underwater placement piers.
Not me.
Y'all do any of that? Okay.
Don't do that yet, MTC, under the river?
So, sometimes you have to. Sometimes you can't case a pier and pour it in the dry. So you have to pour it in the wet, and there are certain ways to do that. You have to usually use a polymer that makes it the water thicker, kind of like a shake. That way it holds the side of the excavation from falling in. But then you have to put a trimmy all the way down to the bottom, start pumping at the bottom, and you pump it all the way down to the bottom, and it starts forcing the liquid up. You can reuse that liquid on another pier, but it kind of decreases a little bit of the skin friction in the bearing capacity. Yeah. So sometimes you have to go a little deeper. But there's different ways that you can pour piers with water.
That's good to know.
Auger cast in place piles. Y'all done any of those? Okay. Okay. That's a little bit different animal too. You know, it's starting to become more popular because a lot of contractors are bringing their equipment to this area, because in the sandier materials and the deeper materials that have water, it's kind of an option that they can use. Rock piers. Any of y'all using rock piers? Okay, that's something that's starting to become more prevalent, where they drill a hole instead of a drilled concrete pier. They drill a hole, they fill it in with rock, and they compact it. And then they put it in layers, and they've got this big pneumatic track hoe, and it hammers the fire out. You can feel it from 50 feet away. And it compacts the rock, and it basically densifies the area around it, plus the column of the rock of a pier. It actually grows, and now it's a little bit bigger, and you can get a lot more bearing capacity out of that. They use a lot of them on parking garages now. Shallow foundations, spread footings, individuals, footings. We test all kinds of earthwork testing, whether it's compaction, lime gradations, cement. I'm sorry?
Proof roll.
Proof roll. Yep. Structural steel inspections, spray on fireproofing, asphalt testing, and then non-destructive testing. Windsor probes, window pins, rebound hammer, drilled cores, impulse echo, GPR scan. So we can supply all that for you guys.
Also done mill thickness on waterproofing for me.
Sure. Yep. We can do all that. Now keep in mind, Windsor probes and rebound hammer testing. A lot of people think that's hey, I had low brakes, come out here and do a Windsor probe. As long as I get good strength, I'm okay. That's really not made to be a acceptance criteria test as a standalone test, because if you read the ASTM standard, either on one of them it's ASTM C803, the other one's 805, it always says for acceptance criteria you should calculate that to drilled cores. So a lot of people don't realize that, and so what we try to educate the client or the contractor is, I've got to drill cores anyway, let's just go with drilled cores. because what it's made for is if I've got a 1,000-yard paving pour and I've got low brakes and I want to see what my strengths are because I've got low concrete brakes, we'll go out there and cut core samples, and we'll develop a correlation curve with this mix on this project compared to known rebound hammer or Windsor probe readings. Once you do that, then you can go to all these other little areas. Instead of making Swiss cheese out of cores, you can just do the Windsor probe or the rebound hammer. So,
Just like you said, Dallas,
Correct.
311T, they're gonna come do the cores.
correct.
I mean,
Yep.
that's what's gonna happen.
Yep. So, a lot of them just, a lot of suppliers will say, well, we'll come out and do a rebound hammer, and if I get 4,000 PSI, you're good. Well, they're taking that responsibility because you don't, the more you use an apparatus, the more accurate it becomes, but a lot of it depends on the actual mix, because the rebound hammer, it doesn't tell you compressive strength, it just gives you a number. You've got a hardness of 38. But then it does have a little chart in there that says, yeah, this is, 38 is going to be around 4,200 PSI, but it's really plus or minus about 20 to 30%, which can be huge on something like that. And I think that's all I've got. Is there any other questions on the concrete side of things that maybe y'all run into on your projects or?
Yeah, sure. I mean, just, in you all's experience with us and other general contractors, where do we fall short in some of, it's probably coordinating, or, for testing, or what are we doing that we need to do better? I mean, you already mentioned having the, on, field boxes to
Sure.
replace those, something we could do better, but what are some things that we could be doing better? I mean, top three.
Top three, communication with scheduling tests. I know y'all are, y'all have your subcontractors. Do y'all self-perform a lot of your concrete?
No.
Okay.
We do schedule the
So you
last
sub it
for our
out.
concrete.
Sure.
Our sub doesn't schedule.
But what happens on a Tuesday afternoon at 5:30 when your sub says, hey, I'm pouring this at 7 o'clock in the morning, you call our dispatcher and they're already gone for the day. That hurts. As long as we have timely to where we can get out there, you will be there. We're here for you guys. If we've already made the schedule and it's late in the day, you have to work with us a little bit. Either we can kind of juggle things around and get somebody out there, or somebody can just run out there and drop cylinder molds off to you. If y'all need cylinder molds for that reason, we can give y'all several boxes, keep them on your job sites. That way, in case something does come up, wow, I can't get a lab out here, have somebody make your cylinders for you. We can always test them, and then we'll just put on the report that these were made by contractors or whatever.
We would make our own cylinders, but
Correct.
if there's a problem, there's an additional problem if you're not certified to make the cylinders.
Correct. And,
You're gonna end up with doing a core, so.
well, sometimes we have guys that don't have cylinder molds on them, out on a job site or something. We say, fill up a 5-gallon bucket, 8 inches thick, rot it really good, and then we can cut cores out of that.
3 lifts of 21 rounds.
Sure. Well, just consolidate it as best you can.
24 hours minimum.
Well,
No, with steel,
not always.
a week.
Sure. Yeah. Yeah. When does that happen?
It happens every time.
No.
on my job.
No, I understand. No.
It
No.
really does,
Sure.
every time.
It happens every time on my job, except for when I forget.
Well, hey guys, we're all human. We all get it. Y'all are busy doing a million things every day, and then at the end of the day, it hits you. Crap, I forgot to call this in, and it happens. But as much communication as we can with our dispatcher, the better.
I fear screwing up so much I don't not do it,
Sure. Well,
but it's only fear.
well, I mess up daily.
People are pretty laid back.
James will tell you I make mistakes every day.
Yeah, no, I'll
But-
just make
Wife will
mistakes.
tell them that, I don't.
I literally.
They're little mistakes though.
I literally, it goes real high on my priority list, get the lab scheduled.
Sure.
It's always top of my mind. It should be for all of us whenever we're pouring concrete. It doesn't say anything.
And we appreciate that. The more the less hoops we have to run through early in the morning, the better. Again, you're asking, what can you guys do to help us? Supply us drawings, current drawings That way the project manager has them. What we do with our technicians, they all have a tablet. We download the most current drawings and we put it in Dropbox. That way the guys can pull that up.
Send you the approved mix designs.
Approved mix designs is great. You know, that way when we're pulling it, we can verify that you're using the right mix. I remember when we walked in earlier, y'all were still having a conversation about a pea gravel mix. You know, the wrong mix may have been developed, you know, ordered or something like that. We can try to catch that for you as well. You know, if we know that you're going to be pouring mix 9341 and we go out there and it's 8764, we can say, hey, you know, are you sure you're using the right mix?
It's the first thing your technician wants when he shows up.
Yes.
It's the first thing I've got printed sitting there to hand him.
Yes.
Is the one sheet of the mix design that tells him what he needs to know.
Yep.
It doesn't need 40 pages.
Correct. Yeah. Yeah. I don't need all this. I just need this.
It's
Yeah.
one page.
And again, you know, be available. You know, I don't know if y'all are usually, you know, superintendents are out on the job site all day long, or y'all are covering 4 or 5 jobs and just doing your round robin. You know, have somebody that we can contact if we run into issue. Hey, this truck came in at a 10-inch slump. What do y'all want to do with it? We can't reject it, but we can notify you before they pour it, hopefully. Hey, what do y'all want to do? Because this guy's wanting to pour it.
Your technicians are very good at communicating. That's
We try. Some are better than others, but we strive to communicate very well with our clients and the general contractors.
I think you probably will find with us, we most of the time have, on-site field guys all the time.
Yeah.
I mean, we don't, most of our superintendents are on that.
On top of it.
They're not
Sure.
driving around. Another question I have is just in general, and I usually ask this of, anybody in the industry that I talk to. What are you seeing as far as, potential labor? And I mean, the guys coming up, I mean, are you all struggling finding techs, or do we have, what's going on out there?
We
Are you
do
recruiting
have
well, or-
we do have issues with finding qualified good technicians. You know, I get applications every week, and you know we're always needing help. I bring in some of the guys for interviews, and I realize maybe this is not the right guy for us. You know, you may be good for wherever you're at, but I'm starting to see kind of little flyers. Some of our technicians are better than others, I'll be honest. We strive to get the more novice guys as much experience as we can at a quick pace. That way they can be more of a value to you guys out in the field. You know, if they're out there, you know, our motto is, you know, in the testing industry is we're there to test and report. Well, it's okay to test and it's okay to report, but if you don't communicate that with somebody out in the field in a timely manner, hey, at the end of the day, you don't want to hear the technician say, hey, by the way, at 4 o'clock this morning, they poured a 10-inch slump over there, or you had trucks that are 3 hours old. You're going to say, well, why didn't somebody tell me then? So communication is key for us.
Stay on your phone. Yeah, Pythagorean. So really, it's not that hard to go to the App Store or the iTunes, go to Construction Master app and just download it. And you have the calculator on your phone every time you need it.
What is it called? I just did that. It's asking me for money. I gotta find another one.
Construction
I mean,
Master.
you have your construction card on your.
No,
Pro.
mine got turned off.
Construction
I'm
Master
waiting.
Pro.
If you're gonna deal with feet and inches,
Get back. I don't even got gas card.
it's just too handy. If you're gonna cut a roof or stairs, it's super handy. So you never know when you're gonna be doing that.
Yeah, how do you do that?
You got it?
Yeah.
Put in 39 feet, 2 1/8 inches.
I did that.
Now, put in 107 feet, 4 inches.
4 inch.
Hit diagonal.
I see, I hit it wrong.
You got a little green symbol in the black field.
39 feet.
Which one is it? That one?
Feet.
That's not it. That,
That one.
107
2 inch, 1
4 inches of
$43.
runnerized.
You can do
I got
either one
39
first.
feet.
You did that first.
114.39.
1,371 5/16 inches.
The problem is we don't have a tape measure that long to measure that diagonal.
You know what? I'll divide by 12 for you. How about that?
Richard, is this right?
1371.
That's it.
Yeah.
114.3 1/8.
So mine came up with inches.
So you gotta hit run, rise,
Oh,
and
yeah,
then
if I could hit one more button.
Okay. So, you get to pick, where you going?
I know.
Sweet.
Anybody else download it yet?
I got the end.
Answer doesn't count, you already had it.
I had to download two of them.
It's
I already won one.
Did you get a cup? Cause you had it.
Oh no, I have the orange one at my desk.
Anybody else downloading the app?
You gotta pay for it?
Yeah, I just paid
Nothing's
$35,
free.
then got told I can't have the gift card.
You do gotta pay for it, but you only pay for it once.
Yeah, pay for it once.
I got
$35
it right
bucks.
there.
It's 35 bucks.
My first
Said it was
construction
done.
master I bought in 1989 cost me $107 a contractor supply.
It's
Still got it.
monthly
Hey, he
Yeah,
said.
for access for a year.
And it's never owned me when I need it. My phone is.
Richard, he said it's a month.
I typed in construction, I clicked on the second.
Mine
one.
was-
I
Yeah.
thought it was one. I bet we do, we don't know.
I don't pay for that.
I bet we don't know. Which one is it?
It's called CM5 Johnston. Yeah, the App Store for you.
Yeah, that's a monthly plan.
You don't want a monthly one.
Well, it's been billing me, you know, it goes to your iPhone.
Important that you have it when you need it,
Is this live, Bill?
Good to go, yeah.
Unfortunately, my Apple card is the only thing that works.
All right, guys, let's go back to it. We're back to the first sheet on our little handout.
Page one?
Page one.
Right, we're back to page one.
What I'm calling this is a concrete handbook. Whenever I got that app, it was just one-time pay. They're telling me now it's a monthly deal, so I don't know.
$5 a month or $40 a year.
Mine was one time.
Yeah,
Yeah, we're
I
grandfathered.
have the orange one at my desk.
The problem with that,
I
they
just
start
use
out free, then they go to one time.
Yeah.
Then they go to, you gotta pay a lot of money every month.
Alright, move on.
sorry. Let's talk about mixed designs, the first thing on here. And what this heading is on this with mixed designs is general reminders and a checklist, 6 weeks look ahead. But like I said, on this, you need to be thinking about these things the minute you get the job. You're doing dirt work, you're still thinking about your first concrete. Anytime submittals are involved, you go, well, we sent them their contract and requested submittals. It's not done. It's only done after it's approved. So it's going to take you forever to get it out of them, get it corrected, get it resubmitted, and have an approved submittal. And 6 weeks is cutting it close. So on mixed designs, does anybody have a question about what a concrete mixed design is?
Nope.
No, of course not. Okay, everybody's got that. It's right there on the, yeah, it's right, right. We got a good lesson on it. It's right there on the structural drawings. It's going to tell you, and whenever you get the mixed design from the sub, it ought to be pretty easy to look at and see basically, is it the right PSI? I mean, that's just, if it's calling for a 4,000 PSI right there on the drawing and they're sending you a 3,000, there's no point in submitting that. Just a quick review of the submittal. I always ask for them and hardly ever get admixtures with their submittal. But if they'll give you admixtures, you don't have to chase down the engineer 2 days before the pour trying to get something approved. It doesn't have to be in the mixed design, just separate admixtures, the product with the specifications.
What about the percentage of it?
That's what I'm saying. It doesn't have to be. It doesn't have to be included in that. If they'll approve the admixture, you're good. You can add it. Getting concrete mixed design with an accelerator, whenever they give you the submittal from the batch, the concrete ready mix plant, having those admixtures in there is hard to get out of them. But getting the admixtures, cut sheet and submittal is not. So air entertainment, all exterior concrete. Plasticizers as needed, but if you're pumping, you want a mid-range plasticizer. Just that simple. Your concrete guy's gonna know it. But if you don't submit that, and then here, right when you're pumping, he's gonna add it, you don't have an approved submittal. There are different products to put in there, right? An accelerator is a no-go if it doesn't say non-corrosive, NC accelerator, NCR, which is also water reducing mixture. But the more of these admixtures you can get in your original submittal, the less you're trying to do a day or two before the pour, through the engineer, back. Okay, rebar shop drawings approved. Now remember, these are reminders you're looking at 6 weeks ahead. You know you need rebar shop drawings, you need them approved. Submit a saw cut control plan. Most plans will show you right on the plan for slab on grade where your saw cuts are gonna be. They're gonna go column to column, grid to grid. It's just gonna be on there. A lot of them aren't, and it notes for you to submit one before you do it. Your concrete guy might not like that they have 30-foot centers on their plan and he wants to do something smaller. Submit it. Not the day before. The typical on the saw cut control joint is like 12-foot max and not more than a 2 to 3 ratio. But you might submit something that's 15 by 12 squares, and that'd be cool. Read the notes on the drawings.
What's when you say 2 to 3 ratio, explain.
Well, if you were going to go 3 feet or 30 feet by 20 feet. So 30 feet, good. 20 feet's good. Compared to some long rectangle that's 10 foot wide, 30 foot long. That's a good question, because when I'm writing these, in my mind, trust me, they make perfect sense. Right?
Okay, your shorthand.
Yeah, so do ask.
Who typically does, because I've never seen it on drawings, who typically does the saw cut plans? I've done them for Howard.
No, you tell your concrete guy to do it and give it to you about 3 times, and then you do it yourself.
Yeah, I was gonna say, they don't do it. So.
No, they will. Jimmy will do it. A lot of them will do it. Size Level will do it. You just ask them for it. They'll mark up what they want. And that's what you prefer, because at the end of the day, they're taking the liability of the cracks, right? You want it to be something they agree to. Then you send it and make sure the engineer is going to agree to it. And like I said, a lot of plans will just flat out show it, but they're not going to show it on your paving, but they might show it on your slab. Concrete accessories. Now this is submittals, but we're chasing on a 6-week look ahead. Review the specs and look at the details on the plans. And like I said, structural's really good about just putting it all right there on the sheet of the plans. You don't have to go find a spec book. But forms, chairs, curing compound, or if you're going to use wet cure blankets, void boxes, shoring, water stop. We got a picture 7.
That is 7.
Okay. So here's the slab set up. If you'll notice on this slab, every saw joint on the detail on the plans, it shows cutting out 2 out of 3 bars all the way across here to weaken that, right where that joint's cut.
To force the crack.
Yeah.
Is that a control joint?
That is a saw joint. So when you see CJ, you've got different things. Construction joint, which is going to start, stop, pour to here today, pour to there tomorrow, construction joint. Control joint is controlling the cracks. You want the crack to be in that straight line and not just wherever it wants to go. All right? Vapor barrier, water stop. What are you asking?
Is it running this way as well?
Yeah, oh yeah, both ways.
Where it's every other's cut?
Yeah. Yeah, so here's one, here's one.
Okay.
So what we've done here is we've painted them and then went back and cut them out. And what you got to be careful is don't cut the plastic. So somebody's got to be putting a piece of plywood or cardboard under there as they go. These right here are grade stakes. And what those are doing, is you go out there on the grid, if you're gonna have a 15-foot straight edge or a 10-foot straight edge, you drive those in, and when you're pouring the concrete, you pour it right across here, and you use those to get your grade going. And you've got a grid. Now you've got something you can screed across. You see them up here with their, and then you got to remember to beat those down as you go. So,
Oh, okay. Get them back underneath.
yeah, knock it. Yeah. So what we did on those, I don't know if it's showing up there with so much paint, but it was try to put some kind of tape or sealant right where they're at. Let me find out where I'm at here.
6.
Thank you. You're not going to pour any concrete without an approved anchor bolt setting plan. So here you are, you're trying to do grade beams. You need an anchor bolt setting plan. On this 6-week look ahead, even if you don't have full steel shop drawings done, if they'll get you an anchor bolt setting plan, you can run that through. And all that, I'm saying submit it, get it back approved. All that's doing is everybody agreeing on what the base plates are and where they're located. You don't need your full steel package for your steel supplier and your engineer to agree on that. So that's a minimum. You need the embeds on site. The hot and cold weather concrete pour plan, that's something we touched on before.
Wonder if the, where you have locations of the steel plant and the steel drawings don't match, and the beam comes out and you've got your plate over here and the steel is 6 inches short.
Right.
What happens?
Okay, so that's going to be a problem either on manufacturer or on shop drawings. So the minute you recognize that's happened, if you hadn't checked it before, Arturo's an expert on this. What you do is you go look on your main plan, it'll give that beam number a number. And that number will go back to a detail sheet. And that detail sheet will tell you exactly how long that beam is, what time of attachment flange, everything about that beam. Right. Then you go in the field and measure it. Well, if it's made per the shop drawing, the problem happened on the shop drawings. Okay. If it's not, you see what happened. This beam is either got mislabeled or built wrong. Yeah. And that comes up every once in a while.
Yeah, that's happened to me.
So sometimes the anchor bolts are not where they're supposed to be.
Yeah.
And then you need a structural engineer to give you a plan of how to correct it.
Yeah, now if the anchor bolts aren't where they go, that is a different subject. So you're going to epoxy some bolts in.
Yeah, instead of having them.
You're going to epoxy some bolts in, but you probably got some bigger problems because your grade beam is all built on the same thing. Right. So if you're going to put your anchor bolt somewhere and it's in the dirt, your measurement ain't right. If it's off an inch, you can get direction on how to correct an inch because you're still going to be in your wall. And you're probably going to just end up with a column that's out of level. You know what I'm saying?
Yeah, but you can't.
That's happened down at
You can get a base
bank downtown.
Well, if it's off an inch or a half inch, it's not that.
Like a 30-foot beam that was off like an inch.
Yeah.
You slot holes on the base plate.
Yeah, you can do that. What I do after we get the slab poured is lay out the grid lines on the slab. Right. And I can check all my bolts with the template on it to the grid line. And you can adjust the bolts over a little bit. You can do an RFI about slotting the base plate over. You can move the column completely over on the same base plate, cut it off, weld it back. Do all that through an RFI, own up to it, document it, and go forward. I had some anchor bolts that were wrong. I sent the RFI. My Uncle John was the dirt and concrete sub. And I sent the RFI. I've got a couple of sets of anchor bolts off. Can we use, Hilti bolts and epoxy, and if so, specify what? The engineer's like, yes, no problem. Use this Hilti bolt, use this epoxy. Have the testing lab witness the drill and installation. It was 30 sets of bolts. We had, that joint was a spine and joint hospital in Jonesboro, Arkansas, and it had like 14 different base details. Well, he had mixed up 2. the E and the F or something. So one set had 10-inch centers and the other had 14, reversed. So all those that were E and F were wrong. And yeah, so I left Friday, I came back Monday, still drilling and epoxying. And I mean, it was quite expensive. Okay, I could get into a lot of horror stories. Cold and hot weather concrete curing plan. Hot weather, what are your options? Additives, ice, blankets after you pour, something. But yeah, the ice in the early morning are what we all do here. Cold weather, accelerator or a high early mix, and blankets. The time to think about that is with the submittals. With the submittals and the admixtures. Otherwise, you're a day or two before trying to get this stuff through and back.
And
Get it. Yeah, and I've had, Jimmy, you got the cold weather blankets? Oh, yeah. He brings out blankets that are just full of holes. They're thin. They don't have any plastic on them. They're just going to freeze to the wet concrete. I mean, the type of blanket matters, encapsulated in some plastic.
Well, and I think, sorry to jump in here, I mean, this 6-week look ahead, folks, we can solve a lot of problems in 6 weeks.
And submittal
we're good at
review.
solving problems. I mean, but if you're looking at things 1 week before, a couple of days before, you're out of time to solve the problem.
Yeah, and I lost Lawrence.
And Chris.
He's having a situation with Bill. I think he's trying to make some phone calls.
Okay.
Yeah, but what I'm saying, and I think all of you are probably the same way, you can solve a lot of problems in 6 weeks. So if you're looking at these things at least 6 weeks ahead, I mean, like Richard said, you should be looking as soon as you got the job. But a minimum of 6 weeks, you can solve these problems. You can have this stuff ready. You can have it there. I mean, you can get blankets brand new from Chicago delivered in 6 weeks.
So Joe asked me to put down a pre-pour checklist. I end up with 4 pages. I broke it up because you don't need to check all these things. But this is still not everything you might need to be considering or think about. It's just the things that came off the top of my head that keep coming up every job. That's coming up, right. So a pre-concrete coordination, plumbing, that's not part of concrete, but you can't separate it. Let's go to pictures 8 and 9. 8, there's some anchor bolts for you. That's for a wind brace, diagonal brace. Whenever your plumber's out there working, you've got to determine right then, what are the slopes around these drains, or what do you need? Is it just local? Is it just right around the drain? You need to set it a 1/4 inch or 3/8 low? Or does the plan show the whole room goes to that drain and it needs to be 1 1/4 inch low? That's when he's setting the drain. And then you've got to go over that again with the concrete finisher. This is what the drains are. This one's this, that one's that. But that's just a coordination thing that's going to happen, needs to happen, and it's the same with electrical. You might have floor outlets. It doesn't matter where they show them on the plan. They got a note up here and says that's not where they really go, and it's your fault if you don't coordinate it. So you get with the owner and get, okay, what's your furniture layout plan? Where do you want these? You document it. And then when they get in there to put their furniture, they move it all around different. But you've already done your due diligence. So it's not just concrete. It's everything involved in the concrete. Yeah. Form board survey, that pops up on some of these cities. It has to be done by a licensed surveyor. You've got your forms up there for your slab, not your grade beam. They'll come around, they'll shoot the elevations. But it needs to be done on a plan that shows the easements and setbacks. You call your inspector for your inspection, he wants your form board survey. You'll notice he's gonna want that because it's on your permit. That's the only place you're gonna get a clue, or you're gonna get surprised. Form board survey. So basically, he's just looking for setbacks from easements.
Is it on every job that's permitted?
No, no.
When does it come up?
It came up in Grapevine.
It comes up more on residential than commercial, but it's pretty.
I read it,
commercial.
I had it, I was ready, I was good. You know, the only reason why is because I read the permit and there it was. Form board survey. I'm like, what the hell? So, no, you'll go along, but you know, you've got so much stuff scheduled and so much going on, and the city guy ain't coming until the day before you pour. You ain't got time to get a form board survey. You're pouring tomorrow. And you can't get them out there sooner because you need your rebar in place so you have something to look at. You got to read your permit. If you're in the same city doing the same kind of thing, it's not as much of a surprise, but we move around to all these different cities constantly. Termite pre-treat. This is a plan that you read your specs and you don't ever see it on your drawings. The specs call for pre-treat termite. They're going to call for you to do the grade beam or the footing. They're going to call for you to do under the slab immediately before you put your vapor barrier down. I mean immediately. And then when you think you've done all that and you've moved on, it also usually calls for a certain percentage outside the building before you do your flat work or your sidewalks. So now you're back to termite guy, come spray around the building after you've graded out your sand. That can fall through the cracks, but it won't fall through the cracks if you'll just read this 6-week look ahead.
So I asked her, why are we putting termite protection underneath concrete? They don't need concrete.
No, they come, they're subterranean termites. They come up through the slab and any crack they can find, and they eat all the paper off the drywall.
They can get through concrete.
Oh, yeah.
Yep.
Oh, yeah.
I thought it was just a leftover city code.
No, it's a real deal, and I've had callbacks because of termite problems.
Wow.
And let me tell you, if you hadn't done this perimeter treatment, your warranty with them is crap.
Yeah. Okay.
So this is, on a normal bid job, this is going to be in there, and you're not going to notice it on the plans. You're going to have to go to the specs. And then it's going to call for this submittal. It's going to show their product. I had a EPA guy in Ada sitting there looking at my job trailer, parked with a state vehicle, run out there and cut a hole in the plastic, get a sample, run back to his car. I went out there and stopped, hey, wait, who are you and what are you doing? Well, I'm supposed to periodically be checking for the percentage of this termite and what the chemical is. And I said, okay, cool. Never heard another word.
Next time, don't just run out and
They were like, what? I really didn't know what the hell he was doing.
That's when you send Jose to go out and tackle him.
Yeah. Yeah.
Yep.
Okay.
Dude, I called Steve Wayne. They had to come out and
there you go.
treat my house and
So-
fix it.
Tell
You
them he
can't
brings
treat it
chemicals
after
in
the
the
fact?
Porsche.
Yeah, they'll come out and they'll go out around your house and they'll pump it up underneath.
If you forget to do it, you're gonna have to go drill holes everywhere, and they're gonna pump it in. Don't forget to do it. Just read this.
Are they little tiny things?
They look like an ant with wings, but the key, if you look it up, is the body. It's where that little skinny part on the body is to tell the difference between a wood ant and a termite. If you're down in Houston, it's very common for them just to come attack your house. Swarm just shows up, attacks your house.
It's like on the cartoon.
Yeah. Oh,
Go
yeah.
in your house or something.
Yeah. It is. That one episode of the Pink Panther, I love that. He's got that termite using him like a table saw, running the wood through. All right. If not already covered in earthwork, which I tried to focus this on concrete. I tried not to get off on bunny trails, but I let Cornell review this, and he's like, well, what about locating pothole? Because on here we do talk about approaches and stuff where you might be digging where you didn't just do a bunch of earthwork. It's going to be on your plans, whatever it is, call 811, get locate. I prefer to always make the sub that's going to do the digging or the excavating call and deal with it. If they don't, you have to. Somebody's got to do it. It's a whole different ball game if you hit a gas line or a light control box wire that you didn't even know that's what it was for and you didn't call. If you call, it's a lot less problems. It's like, oh, well, we didn't mark that, but yeah, okay. If they mark it, then you're going to not hit it because you're going to be careful. The CMU dowel coordination drawing. Let's go to picture 10. I think we may already. Okay, never mind. Termite pre-treat's 10. Stay there. My bad. CMU dowel coordination drawing. So here you are going along. You've got your rebar shops. You're doing everything. The rebar shops are not going to tell you exactly where to put these dowels. It's coordination with the CMU shops and contractor. Every one of those dowels have to come up exactly in the cell where it goes. You go off a corner and you measure 4 inches and then you measure 8 inches. That's your first 2 dowels both ways out of a corner. And then your plans tell you what centers. And you measure off that second dowel, the one that's 4 plus 8, 12 inches off the corner, and lay out those centers. You think, okay, well that's good, but that's not good. You got to skip your doorways. It might call for 2 dowels on each side of the door. Then you've got to locate your CMU control joints. You got to have a dowel on each side of that. But you can't disrupt your main on-center deal. When they're laying blocks, they just go one after the other. So you've got to coordinate all that in there. So a CMU, yeah, I did the plan so that they would be able to put them where they went, because CMU guy just wouldn't do it as usual. So that's the next step you have to go through, is when you can't get the sub to coordinate, you got to just take the bull by the horns and do it. And that's what I did on that job. That'll come up anytime you see CMU. Testing lab, they have to be pre-set up with a contract ahead of time, not when you need them.
Right.
This is the 6-week look ahead. And when they get set up, they're going to assign a project number for your job. That's their project number. When you're calling the lab, have that project number. It saves a lot of mix-ups, especially like at Bell, and there's 3 little jobs going on right there in the same area with the same address. They might have different names, but it gets screwed up. I've seen it. Send them the plans and the approved mix designs when you set up the lab. This is more on PMs right here, but your superintendent, you need to be making sure they're doing their job. Because if they don't do it, you got to do it. Send them the structural plans, send them the approved mix designs. The testing lab then has what they need. They're getting more sophisticated. They show up with their iPad, they can pull up the job, they can find everything they need right there. They can see the plans, they can highlight the area that you're pouring, they can see what mix design you're supposed to be using. You're going to have different mix designs for piers, grade beam, slab on grade, paving. You know, your admixtures are all on there. Are we back to termite pre-treat?
It's in here twice in this.
Okay, well this time is talking about grade beams and directly before vapor barrier. So those really went together. All equipment submittals needed for coordination. That word all is so big. I put it capitalized, I should have made it bold. There's so many different combinations of what equipment you may have in that job. Most of it usually is provided by owner if it's not a mechanical or electrical thing. So you need to be requesting those cut sheets, that product, from the owner, through the architect, of course. Some jobs you'll start and it'll literally have that in the specs, the owner's equipment. I mean, if you're doing an ice maker, you got a floor drain, you need to, or a floor sink is what it'll be, you need to know where to put it so the feet don't fall in, or it's a kitchen, you got all this equipment to coordinate. You need to know where to stub things up. You've got some things that require housekeeping pads or recesses in the floor, or there's just, what if it's a freaking giant, what was that layer machine thing we put in? The giant piece of equipment that went out there at the gantry. Yeah. What was that thing? That giant piece of equipment that M. Torres provided? Taping machine. Well, that's a pretty major piece of equipment. You're going to need all the cut sheets, but it's not just something that major where it's like obvious. Sometimes it's the little stuff.
All that stuff, yeah, that's gonna cause you to have to come back and saw cut, change things.
Yeah, or you're just taking off and you really don't even.
Check it, on that thing, they showed the trench to connect the equipment at the, inside the wall, I think initially.
Yeah, that's what I'm saying.
The machine was wider than the steel columns in the building. Like,
You-
come on, guys, you gotta make the machine fit
Yeah,
the building.
you need all equipment submittals needed for coordination. You've got to be asking for those things way ahead of time, or you're not going to have it on your slab or be ready for it. And then it's like, oh shit, I didn't know you were putting that in here.
Yeah,
It might just be a little dotted box on the plans.
the dash line in M. Torres was the drain.
Yeah, I mean it.
We almost missed it.
Yeah. Okay, so here's the just basic checklist that you need to look at and actually interact with and fill out. It's on the bottom half of this sheet. I printed out a nice big one. Take that, and Chad, you're going to have to get the others back there somehow.
And this is for every single coat.
Every pour.
So if you have layers, you can have.
Every pour.
Concrete
You
coming
just
out
date
truck.
it, time and date it, for what for, what location.
So, right, so this
Keep,
this part where I've got it in bold in the check-off boxes, this is what I normally just write out and stick on the wall in the job trailer. But before you get to filling that out, the top part of this is mostly just a conversation that you could very easily put on your 2 or 3 week look ahead, and it's a conversation with your concrete subcontractor. To just go over these things. And it's the same thing you go over, and all of you's done that ever poured any concrete. It's just a little bit more organized here. So access and staging, Chad, you brought that up. A washout pit, where are you gonna put this crap? Who's doing it, when? Manpower, this is something that Bill reminded me of. Concrete guy, do you have enough people? We're doing this. You got to have a flagman. You need somebody over here doing that. Are you finishing this, or did you subcontract some finishers to come in? You know, are you going to be able to? Yeah. Well,
We just poured 120 yards over it.
yeah,
How did Bell, it was on
Guys didn't back up.
yeah. But it's normal though that a concrete company, you basically have 5 guys. They do all the setup and everything else. But when it's a big job, they hire in rod busters to handle tying all the rebar. They'll come in and tie it by the ton. They're fast, they know what they're doing. And whenever you need 30 finishers, they don't keep 30 finishers in a box at the office.
Yeah.
They hire finisher companies. They're all over town. They have the ones that they work with, maybe 2 or 3 of them. If one of them's booked, they go to the other one. And they're the ones that are really trained to come out and do the finishing and have all the ride-on troweling machines and all the big equipment to handle a big job. But what you want to do is talk about the manpower. Who do you got? What's going to happen? Do you have enough men? Because Bill got stuck on a job where he's got 6 guys and he should have had 16.
Which one? Which one?
Over Ball.
Do they have green card?
Oh,
They
Those
did
guys
security.
were working that concrete to death, and they were getting tired, and it was getting thicker, and it was getting
Well, it
hotter,
was
and
that
they were getting
concrete.
tireder, and the truck is sitting out.
Remember there was a concrete with all that fiber in it. They were
Yeah.
shoving down bushels
It
of
was-
fiber through
It
that
was tough,
pump.
and then, I mean,
Yeah,
we're
it
like,
was
are you
crazy.
okay? I mean, mean, they're calling their office, they're trying to get guys from other jobs to come and help them, I mean, but
Yeah.
at one point they just, all right, we had a cold joint, it was an ugly
It was
cold
getting-
joint too.
Yeah, it was getting
It's just
stuck
like
in
where
the
they
car.
stopped working and left.
Yeah, well, hey,
Yeah.
it can really wipe you out. My experience with something like that, I rolled into Houston. I was going to frame a house for my dad. He was a general contractor. My Uncle Donnie was finishing the slab and pouring the concrete, his little 3,000 square foot house. And me and my friend rolled in, pulled up. He's out there troweling. There's one other guy working, troweling. He's running the finish machine. And it's 90-something degrees. It's 90-something% humidity. And he's a big guy. And they're about to lose this stuff. He looked like he's going to die. So first, we jump out with a float, and we got no experience. We're working the edges. But, he's like, I can handle it. Well, this wasn't North Texas. This was Houston, and I mean, humidity will wipe you out. But but anyway, it's a good thing to have that little conversation about manpower. Then you're going to have to discuss weather. I always put the weather on the concrete sub to make the call. You got 50% chance of rain. He's got the most riding on it. If you've got earth form grade beams, it's earth. It's probably carton forms in the bottom. Yeah, they're wax coated. They'll handle some humidity. Rebar. You got a week's worth of work in this thing. If it rains before you pour, your ditches start collapsing. You got to tear out all your rebar. You got to start over. So you're telling him, no, you can't pour. And then it would have been fine. And then that weekend it does rain 10 inches. I mean, he's screwed. You just cost him a lot of money. So I put it on him to a certain degree. If it's going to be a catastrophe if we don't get it done, your call. On a slab, you've already got your vapor barrier down, rebar. It's not going to ruin everything. You could be more like, let's wait. You got to worry about the finish. I did a surgery center in Beaumont. Again, my favorite Uncle John doing the concrete. He wanted to pour it on Saturday. I'm out of town. I'm like, no, pour it on Monday. It's supposed to rain. I want to get it poured before it rains. Okay, it's your call. I left out of there. They're troweling. It's done. Test cylinders are made. I'm driving north and run into a fall rain. That's the big drop. Ain't gonna quit. It's going south. I get back Monday morning, they're still out there finishing. They didn't finish that whole time, but it beat the top off of it. They're out there having to throw Portland and fill in. And it looked fine when they got done, but it made a soft top on it. And after you run all your scissor lifts and everything else on it for 6 months, all that powder stuff comes off and you start seeing what it was. So we had to floor decks the whole thing, with the flooring sub. But I'm just saying, when it comes to weather, let your concrete contractor help really make the final decision whether you're going with it or not. This is the 1 or 2 week checklist. You need tower lights. Do you have everything you need? You got a vibrator. If you don't have a power pole, you got a generator. And then there's a big blank here. That's to talk about whatever the heck I'm not thinking about. Fill it in. Yeah. No, seriously. Seriously. And it's something I didn't put on here. Yeah. No, I didn't put it on here, but it's a big one. It's a big one when you're out at Bell. So you get date, time, and number of yards established from him. Testing lab, when you call and schedule them, you're pouring a early morning 4 a.m. pour or whatever. They're not going to open their office till 8. You ain't going to talk to nobody. Ask for the technician's name and cell number that's going to be coming. That way, whenever everybody's there and you're starting to pour and the lab guy ain't there, you got nobody you can call. At least you got a guy's name and a phone number, and you can be calling him, saying, hey, where are you? Don't stop the pour. They'll show up eventually. You're doing a big pour. Okay, if not, you know, try to do the rebar inspections the day before, not the morning right before. A lot of little jobs, you do the rebar, you schedule it out. Come an hour before and do the rebar, and then stick around and make cylinders. If you can get them to come and do the rebar inspection the day before, it's much better. It gives, you got rod busters or whoever's tying the steel, they got a problem, they fix it right then. You got plenty of time. It's better than an hour before. So once you got that date and time schedule, then you fill out this down below. Call your lab guy and schedule him, write it on here. When it's approved, check the box. Schedule your city inspection. It's gonna have to be the day before the pour. It ain't happening day of. Where it does happen day of, we'll get into in a minute, but that's gonna be piers. Even though you've got them for rebar, you still gotta schedule them for the time of pour to do test cylinders. Notify your plumbing and electrical superintendent when you're pouring. You need them there. The plumber needs to be watching his drains, his plumbing. If something gets messed up, he can fix it. Same with the electrician. You got stuff stubbed up, they hit it, it's broke. You need to dig it up and fix it. If they're there, it's not as near a big a deal as if they're not. In Texarkana, I was doing a surgery center, doing the paving outside. There's a clean out. We pour the paving, they're moving in. I mean, moving in, everything, coming. All of a sudden, they're coming to me going, hey, the toilets are backing up. And I call the plumber, and he's at fish taping everything. Out in the parking lot, we were tailgating the concrete. Rebar stays down, you pour, and you pull up the mats as you go. Well, they had broke off a clean out from the main sewer line. Whoever's finishing the concrete just stuck it back in and finished around it. It wasn't even on top of the pipe. It stuck right there in the parking lot. All finished, looked nice. You open it up and it's just cement and dirt under it. And it wasn't even on top of the pipe. So I guess the truck ran over it. They didn't tell me. He was probably scared for his job or whatever. That went down that pipe and went both ways because it was a Y, so they could fish out either way. It went both ways about 5 feet. So we had to cut out about an 8 by 8 section, excavate down. It was about 6 foot deep there. Dig back and tunnel a little bit and fix it. All why they got surgery scheduled for the next week. You know what I'm saying? This ain't no game when you get to that point. This is a money-making building, and there's stuff scheduled to happen. Okay, so anyway, use that lab's project number when you're scheduling them right there. Make sure, I don't know, I may still have this wrote on here somewhere. I always print out the mix design for what I'm pouring that day and a copy of the plan. Let's try another picture, maybe 11. That's a schedule. We can stay there at 11. If you can just print out a copy of the plan if you're pouring different phases or sections and just highlight what you're pouring and date it and give them the mix design. When the lab guy shows up in the morning, yeah, that's what he wants to know. He's going to check the truck, do the testing. If it says you need 2% air and he's getting 2.5%, you got a better chance of it getting wrote down 2% if he knows what he's supposed to be. I mean, seriously. But it's also he's checking the truck to see the mix design's right. It's hard for you to be there checking every truck, but he is. He's right there. And you tell him, you got any problems, tell me immediately. Okay? That's just a short conversation with the lab guy.
When you don't have a lab out there, you gotta check that ticket and make sure that it's lining up with what you're mixing.
Yeah, you need to be trying to check the tickets yourself too. I always check the first truck. I feel good. I've had jobs where a different supplier shows up and gets in line. It's not even the same concrete company. I don't know what these guys are smoking at 4 o'clock in the morning. They just fall in line. Yeah, I'm serious. They just fall in line with the other ones. You're not even the same company. Get out of here. But they could come from a different batch plant and still be screwed up because they got the wrong one. But that's something to go over with your concrete guy too, is the mix design number. All right, so this first sheet was about, hey, get ready to pour, and what are we doing on pour day checklist. These others are more specific for each type of phase you're doing. This one's piers. Well, look at the schedule at all the crap that's going on here. When you're in a 3-week schedule, and you're talking about you've got 100% complete form work and anchor bolts. Anchor bolts are all sitting there with the forms. You've already installed your rebar, your plumbing, void boxes, rebar, electrical, OOFR, city inspection. Don't miss the OOFR inspection. And that's another one of those. It's a ground wire that goes to the main electrical panel. That's named after a name dude named OOFR. OOFR. Form board survey, if there is one. This was from my actual job me and Bill did at Grapevine. City foundation inspection, lab scheduled pour slab. And this is building 2, and this is building 1. These things are stacking on top of each other. And as soon as rain hits, you got all these people to reschedule. Start over. Termite guy, city, lab. Sometimes it's never ending because the rain just keeps coming. What's our next picture? So on piers, schedule city inspection for the day you're drilling piers. Some cities will just say, well, we don't come out and do inspections on piers. Just have your lab guy. Some will say, yeah, we absolutely do. Well, they're not going to stick around all day. You've got 60 piers to drill. When they get there, what they want to see is your rebar gauges tied, and they want to see the testing lab. You got those 2 things, you just passed your inspection. On your cages, normally have those done in full length, 60-foot lengths. This is a big cage, and I put that picture on there. That's from that big job in Ada, just so you can see a big rebar cage that went in a pier hole. That was a 66-inch pier, and that's a 60-inch cage. And that was the biggest I've ever seen. Yeah, that's a big pier. So the reason we're doing 60-foot rebar lengths is you don't know exactly where your bearing's going to be. Do we got 12A? Is this it? So what you're going to start out with your geological survey is it's going to, when they do their borings, it's going to show you what's down there. And then the engineer is going to design where you're going. Normally it's going to be all the way down here to this gray shell, and then it's going to call for a socket, 2 feet, 3 feet, whatever. The only person that's going to determine that you hit gray shell, although everybody and their dog saw it come up, is the lab guy. He's the guy that determines when you hit bearing, and then your socket, and then he's going to measure it and document it. So he's scheduled, when you schedule him, he's scheduled for piers full day for whatever you think the duration is plus a day. If you think you're going to be doing piers for 4 days, you schedule him for 5. You say until we get done. Once he measures that, then they go over and cut the steel. And you remember back to that last plan, each pier comes up to either the bottom of grade beam or a foot below slab or whatever. So they're going to deduct for their feet on the bottom. They're going to deduct how much to cut off total below grade. Cut the pier cage, in the hole it goes, concrete goes next. Let's see, we covered 12A, B.
Put them rollers on there to keep it centered too, don't they?
Yeah, that's going to keep that rebar off the dirt. It needs to have whatever it calls for on the plans, 2 inches clear. Same with the feet. So you need that geo report on hand. You need your testing lab on hand. They're going to determine the depth. When the job's bid, they'll say, okay, figure 30-foot deep piers. And then you also do an alternate on there that says this much add for additional depth, this much deduct for less depth. Every time I've done piers, they've rarely all come out the same. I've had them to where they're as much as 10 foot different. What's underneath there is sloping over a long period. And sometimes they come out pretty uniform. And when you're doing bale piers, these typically just bear on dirt, and they're not expecting to go find gray shell. When I was at Beaumont, I had bale piers. The building was 19 foot above sea level. And so talking with the lab, they're like, yeah, you don't want to go 2 feet. That movie theater sank. They condemned it. Everybody sued. So they literally, we drill down there. The spool's coming up. The lab guy grabs that, takes this little handheld pricker, and goes, that's it. But bale piers are normally all universal the same depth. But you don't know what that universal depth is for sure. And if your concrete guy has cut all of his cages for 10-foot depth, because that's what it shows on the plans, you've got them all lined up and tied, lab guy goes, no, you need to go to 12. You're dead in the water. You do not splice rebar on pier cages. So I think I just noted all that. I don't know where I'm at on here. Sockets, bale piers. Okay, pier hole is clean and dry. You can do 60 piers. The 61st pier, you got water spraying, looks like a water hose down there at 12, 20 feet, 4 feet, you never know where, just spraying in. You need to make sure you have a pump on site ahead of time that's capable of the head pressure of however deep you expect to go. And what you'll do as soon as that happens, you throw that in there and you start pumping. But you can also you've drilled this hole, you got water seeping in, you're pumping out. You look down in there, there's hardly any water, it's all working. You're going to quickly throw your steel in and start pouring. Lab guy's good with it, everybody's happy with it, it's industry standard, that's what you do. If it's bad water, you're going to have to case the pier. What you do right here is have them drill another hole, maybe 5-6 feet deep. And then you know that your interior pier you're pouring to here, or you're under going to be a grade beam pier you're pouring to here. Then you cut this out right here, a trough over to it. Now when you start pouring that concrete, here comes the concrete, here comes the water on top of it. The water will run over in this relief hole, and you're not stuck with it in a hole right there with a bunch of soup mix on it. You have a place to go. These are handy things to kind of know right before you pour piers. Your concrete guy will probably know, he might know, the lab guy maybe know. Yeah, I learned that with Size Love on building 2 on Boathouse Retail. Building 1, no problem, and most of building 2, no problem. But building 2 had 3 piers on one end that just kept making water. So first thing I learned is their pump sucked. You can find out what pump they're going to have. You can look up the cut sheet. It'll show you the head pressure, how many gallons per minute at 30 feet, 40 feet, 10 feet. It should be rated for at least as deep as you're going to have some decent pumping abilities, gallon per minute. And it's right there on the cut sheet, and you can know ahead of time.
Those Home Depot pumps don't normally clear out.
They've got cut sheets too, but what you're looking for on this is called a trash pump, and not necessarily a floor pump or whatever you're going to find at Home Depot. But Home Depot does have trash pumps. Sometimes it's hard to find them because they're in different spots in there. But what you want is a trash pump, and you don't want to worry about you being the one having it anyway. You want to make sure your concrete guy's got it, and then you want to know what is it he has. If he's got a trash pump with a 2-inch flexible hose on it, you need to reduce that to a 1-inch hose so you can get the head pressure and the pumping ability to get it out of the bottom of that pier hole. because it won't have enough pressure to do the 2-inch. Okay, let's try another picture and see where we're at.
Drilling for piers,
Okay.
drilling for piers.
Okay, so we've talked about pier holes are clean and dry, confirm rebar, mixed design. On piers, your structural plans will almost always call for a 7-inch slump. Slabs and everything else, it's always a 5, plus or minus 1. They want that pier, that concrete to get down in there solid, not have a bunch of honeycombs and voids. And the 7-inch slump is what they're looking for, and it's going to dry out really well. That ground temperature is the same, 55 degrees. All piers must be poured within 8 hours of drilling. You drill that hole, you either pour that pier or you fill that back in with dirt and try to tamp it in if you can. The reason for the 8-hour limit is after you drill that hole, the ground is pushing in that hole. So your 20-inch hole, tomorrow morning it'll only be a 19-inch hole or 18. Your rebar might not even fit down in there right. But when that's pushing in like that, that's what they're relying on for their calculations for the skin friction. The skin friction, if you can think about trying to pull something that's stuck in concrete out.
Chinese handcuffs.
There you go. There you go. So that's why that rule's there. And you can't pour 2 piers that are within 6 feet of each other or whatever your plan says in the same day. When you pour one, if you drill another hole right beside it, it can blow out into it. You need it to cure out overnight, and you can drill it the next day if it's close by. That would be a bad lesson to learn on the fly.
And you have to plan those out for access.
Okay, all your special inspections are normally listed out just as clear as can be on your structural drawings. If you go on flip, it'll say special inspections. It'll list everything from earthwork, concrete, steel. Read the notes on the plans. Before you do piers, these are the things you need to make sure you have before you start. Safety, you see the hole cover? You right there. Yeah, right there. So you want to have those. You see that cage they put around while they're drilling? Yeah, those don't get used very well, hardly ever. Yeah, have them on site.
Safety?
Yeah,
Safety cage?
yeah. Have them on site. Use them the best you can. The hole covers are critical. The minute the hole's drilled and people are going to the next one, it's got to be covered. The only time I've had somebody hurt on a hole, but wouldn't that be something? You're looking around, you had 7 people and you got 6. It's just that quick, that quick. The only time I've had somebody hurt was JMC's guys, was at the Sound. We just drilled the pier hole, we covered it, we're waiting on a concrete truck. And this was a one-off, it wasn't out in the building. This was for some artwork. Oh, here's the truck, he's backing up. He grabs the plywood, picks it up and steps forward.
How big was the,
No, it skinned it up.
how big was the hole?
It was a 2-foot hole, but it had the rebar in it.
Oh, okay.
We were ready to pour. So his leg went down and hit the cages and kind of stuck in there, and one of the rebars cut his leg. But literally the hole cover's there, he's moving the hole cover. His steps forward, lifts it up.
That was my wife's first ever call with a fireman, person fell in a pier hole.
Yeah. So the safety part of that's a real thing. So have your plywood and barricades on site before you start. There's no starting without those. You can make a shot stick. This, I may be wasting my time even just explaining this one to you, but here we go. You can read number 2. This is something I do sometimes when I've got a bunch of piers to drill. Here we are on this example. This pier stops down here 2'8" below where we're all standing up here. Brick mold at Home Depot. The little laser level deal snaps right onto it. connects to it just like a shot stick. Take a hinge, which is a big hinge, which I just drew on there the wrong way.
Whoa.
Remind me not to do that again. Okay, thanks. Put the hinge on here, a piece of wire. You can put that nail through here, lower the shot stick down into the hole, and reach down there with a extended handle, big framing hammer, and just tap that 60 penny nail into the side with a piece of flagging tape on it. And you can do all that right from up here, and not what I've seen is people literally butt in the air, leaning in here to mark that on the bottom, you know, with their feet out here, down in the hole. You can do it from all up here. Brick mold, hinge. Oh, did I leave off the screen door hinge spring and a piece of wire? That way you can release the hinge that's holding the nail. And like I said, that's probably a waste of time, but I've done that. I've done that when I'm. I'll look for a picture of it. I've got one somewhere, but yeah, my Uncle Dick taught me that one. And I'm like, well, that's pretty neat. It works because it takes some safety out of this. You don't have somebody, their butt right at the hole and their torso down there trying to mark it. Now, when you're pouring that, when you're pouring that concrete up, every inch or two you go over is an inch or two of concrete that's hard to get out of a hole. And if they've got a shot stick and they're trying to shoot the grade as you go, it happens. But if you've got a nail on the side and the flagging tape when we're pouring it, you can see what's happening. You can stop right on it a lot better. Have a large beauty mirror on site and a good flashlight. Nothing works better for looking in there to see who's in the hole or what's the bottom or where's the water than a big beauty mirror. You just take the sun and shine it in there. It's the brightest spotlight you ever saw. But if it's cloudy, you better have a really good flashlight. Really good flashlights just don't do as good as what the sun does with a big mirror. I learned that by concrete guys going out and taking the mirror off their truck. It would snap off and using it. So I just went and bought a large beauty mirror, and that worked really well until the lab guy said, oh, that's cool, and stole my mirror. No. I know right where it disappeared. He said, that's really good, because this is a nice big one.
That's nice. Yeah, he wanted it.
He took it. Yeah. Okay. Accessories and anchor bolts, you know, you're doing piers. Most of them have grade beams on top of them. You don't need any anchor bolts, but the interior piers, if they don't have a pier cap or any kind of cap on them, the piers pour right up to 1 foot down. You set the anchor bolts right then. You got to have them on site. If you don't have them on site, you don't get to set them. Funnel and trimmy. Everybody knows what a trimmy is. A trimmy is a flexible hose that goes on the bottom of that funnel. You're not allowed to drop concrete more than 8 feet. This will come up whenever your engineer shows up on the job when you're pouring and you don't have it. It's right there in the specs. You heard our concrete guy mention it. What the problem with dumping it in, and the way they've always done it for years, they back the truck up to the hole, you got your chutes coming down, they take the second chute and they turn it up, forcing the concrete to hit it and drop straight down. If the cement is hitting the rebar, it's separating the aggregate from the cement. And it's also could start building up on one side. And when it does, it could start leaving big voids. Therefore, what this is doing is centering it down the pier cage. The flexible hose, the same thing. The problem with the flexible hoses is they like to get caught up in the frickin' rebar. If you're gonna do piers, have all of it there, but at least use this. and this is fiberglass. You can pick it up by hand. You can use it. Once you get within 8 feet of the top, you don't need it anymore. You get rid of it, and you can see what you're doing. Right. I've always had them on site. When I did Raytheon, I talked to my concrete guy about all this stuff, just like on this list. Have this, have that. He brings a giant steel one you can't even handle. You need a freaking Bobcat or something with forks on it. Lord. Then here comes the engineer to inspect, and that's what you got, and just have the right thing. People are used to it now if you're doing piers. Concrete companies are used to it. It used to be, like I said, they just turn that chute up and drop it straight down. I've probably done at least 1,000 piers that way, and I've done 1,000 this way. Vibrator, typically it calls for you to vibrate the top 4 feet of the pier. 2-inch trash pump rated for the head pressure, embeds and anchor bolts. Dowel bar safety caps. Let's go, we're missing some pictures here. 16, 17, 18, 19. Okay, right there, back up one. That right there is a light pole base. And that's just a general reminder when you're doing light poles. You drill your pier, typically they're 6 feet on a light pole. You've got a ground in there, you see it? And you've got your electrical. You've got to have a city inspection. And you know how piers are. You like to get this stuff done same day. They got to call in their inspector for that day. So on a light pole, you drill it, you notch in over there 18 inches deep, stub in your electrical through the rebar, tie your ground wire, set your sonotube. Wait on that inspector while you're doing the next one. Usually he doesn't want to see all of them. He's good, he shows up. If he don't, that picture right there and pour. Maybe one back a little further so you can see what side it's on and not just from any job. It's all you can do. You can call him in, you can't make him come. You can tell him to request AM inspection. But at the end of the day, do one, go to the next one, go to the next one. They usually just show up. And they go, oh, okay, you're good. Passing it up is a problem. Dowel rebar safety caps. Let's go to another picture. There we are pouring, using our funnel. Got our vibrator. That was a fun job. That's piers.
Going back or forward?
Keep going forward.
That's the one you had to put those little bladders in that.
Yeah, back up a little bit. So I put that bladder dams out there. I got the idea that from watching Oak Island. It's a stupid, slow, boring treasure hunting show.
I know exactly what you're talking about.
So they were wanting to go out in the bay and do it, and they used these bladder dams. And then we had this conversation, they want to do this deck out in the lake, and these buildings out in the lake. And so I Google, and there's a place in South Texas that has those bladder dams. I get them, we put them out. Here comes 2 people, one after the other, the same day. Oh, we tried that over here on that pump station. Those things don't work worth a shit. We followed the directions, and we put this fabric down, geotextile fabric down. It was 15 foot wide under all that. Chad knows. That geotextile fabric saved us. It kept the water from undermining that with little fissures that would wash out. They didn't do that whenever they did theirs. We followed the directions.
Yeah,
So you can go out at the Sound and go out on that building and check it out. But those other 2 retail buildings and that bell tower there, I did too. I say I did. We did. Chad had a lot to do with a lot of that up there. I had him up on a lift. Yeah.
Yeah, I heard about the boat.
Thought there was a boat down under there?
No, we bought one. Just a little baby.
Maybe y'all found some treasure boat down there.
All right. Here's reminders for grade beams. Know what you're pouring and have a bulkhead plan in place in case if you're not going to pour it all. When not pouring the grade beams or slab and completing one pour, submit a construction joint pour plan. And that's back what Mark was talking about before, whether it's construction joint or control joint. Right here, yes. This is a grade beam construction joint pour plan. So when you're doing grade beams, if you're not going to pour all that at once, you need to make sure you're at least one pier out of a corner to break it off. And then when you break it off, some plans will say on a third or in the center third. Some of them actually say center third and some say on third. Read your plan, but submit it ahead of time. Make sure they're good with where you're going to pour to and stop. This comes in whenever you're like, holy, we're going to do all this at once. Now it's calling for rain. Let's just hurry up and get half of this done, or 2/3 or a third. Pour that, let it rain and be all the problems, and then go again. Carton forms, we talked about that a little bit whenever those guys were here. Is anybody, the void boxes, in the bottom of your grade beam, it's a cardboard box. You can get them, here's your grade beam, here's your rebar, your cages and all the crap, and here's either earth formed or wood formed. If you will submit a trapezoid box, it looks like this. I think I'm drawing that wrong. I did. Dang it. It looks like that. What happens when you pour that, the concrete will come down here and fill this little leg in, and it'll save you having to come back and put soil retainers. This is the cardboard. Do you see how it leaves that little pie-shaped leg of concrete on each side? Yeah. So, I don't know if we have a picture of that. That's fine. Anyway, if it's calling for carton forms, those are soil retainers. You see them? Go back to, that's soil retainers. That's an excavated, formed, and poured grade beam. Yeah. And then you put the soil retainers back to keep the dirt from going in where the void boxes are. The void boxes held up the concrete while you poured it. If you'll submit the trapezoid box, you don't have to use those soil retainers. Just that simple. It just takes that out of it. It's one less thing. If it's, most plans will say no earth forms. You have to, dig it out, over excavate it, dig it all out. You can get that changed if you can show them how you can smooth the sides of it, because they want the dirt to move up and down without bonding to the grade beam. You tie your grade beam steel above the ditch, which we saw back 7 pictures ago, and then drop it down. It's just much easier. You're trying to work in a ditch and tie all that rebar. Put the 2x4s across the ditch, tie it all above it, and then just drop it down. Did you want to go back and show them that picture again? Because we just skipped over it. Yeah, all that's tied up there above the form, which is earth form, and we just drop it down in there. Now, see, that's up where you can reach it and see it and do it. Let's go forward a picture. Keep going. Right there. That plumbing, those are sleeves for the roof drains. They go through the pilaster caps. If you don't coordinate your plumbing and everything else going on when you're pouring the grade beams, you miss that. So you don't want your pipe directly against the concrete. So it's got a sleeve and then the pipe. That way any movement doesn't affect your pipe. And usually it's your pipe that's moving. Yeah, your pipe is being pushed up and down with the dirt. On all concrete pours, any PVC any pipes coming through the concrete like your slab, you have to wrap them with a bond breaker with plastic. That's going to be part of your inspection when the guy comes. The plumber typically doesn't do it. Whenever they're doing the vapor barrier, make them wrap about whatever the height of the concrete plus, 12 inches. I've got sleeves there, so it's not relevant for that picture. When you're pouring grade beams, you're generally pouring them out of a truck, or even if you got a pump, alternate your placement. You're going to go all the way around this building, pouring that grade beam. Pour 3 trucks here, go back around where you started and go the other way, pour 3 trucks. That way you eliminate that cold joint from it waiting until you pour it all day to get back to where you started. Just alternate your trucks back and forth every 3 or 4 trucks or every hour. Eliminate that big cold joint in your grade beam. All right, now we're going to go to reminders for slabs. You can turn the page. So know what you're pouring. Let's go to picture 37A. Something's wrong. Yeah, we are missing a lot of, those are all grade beams. That's embeds for wood. Hold on, let me just talk these out. That's where we've marked where the control joint is in the CMU.
Okay.
Carry on. There we are. We call those stab dowels, but those are slab dowels that ties the grade beam to the slab. He's pointing them all in the same direction, but when it comes time to pour the slab, we'll bend them around, pointing into the slab. You do that so you can do all your other work without them being in the way. Your anchor bolts are set. That's a pilaster. There's your carton forms. You see this foam spray? You're keeping all your concrete in there, not letting it run down and fill up that box. Carry on. This is an earth form slab that originally called for no earth form allowed. We used plastic to slick the inside. We used a corrugated plastic sheet on the outside. Of course, we formed the top 3.5 inches there. That saved us digging out a 6-foot wide ditch, forming it all, pouring it, and then backfilling it all.
This is like the political signs that are stuck in your yard, that little
Yep, it's a corrugated plastic.
plastic. So that's
So-
what he's saying is on the outside of the form.
It goes all the way down the ditch. Plastic.
There, and it
Yep.
creates that smooth side.
And in the bottom, we used a trapezoid so we didn't have to have the soil retainers. All that saved a lot of time. Here's a big footing where we've got big concrete columns going on top of it. You can move that over and see the whole thing. And there's it is after it's poured. See it worked out, all that layout. Next. Okay, here's where we were just at on this. Know what you're pouring and if in phases, mark it. This is one that Mark did for the rock. You see where we separated what we're pouring, where the construction joint is, what phases it all pour in. So we've got pits and 2 different slab pours and submit the control joint plan. Am I back on the same page? No.
When you're talking about slabs, that's what's going through the slab.
Yeah. I just feel like I'm rehashing something we already covered. I think I did because it's in the main checkoff. Slopes to drains. You want to know what your finish is going to be before you're pouring. That's not a good question for the concrete guy to be asking you while he's finishing the slab. And that's usually when it comes up. Okay, so if you're going to be putting anything that's going to bond to that with glue, you don't want a super hard finish. You just want a regular finish. The porousness of it helps it bond to it, okay? If you really finish it out hard, and that last slab you just saw, that's going to be an epoxy floor. You can finish on that all you want. They're going to come bead blast it so their stuff will stick. You don't need to. It's a rare thing that you need to sit there and finish on it. You know what I mean? Normally just regular finish, not super hard trowel. You don't want it to be ringing out. You don't want it to look, polished. That's just bad for flooring. It doesn't bond well. Next. This is a structural slab. All that gets carton forms. You're looking at we just put termite treatment in it. That gets solid void box. Here we are with auto level. So.
How big is that? Is that the one?
Yep, that's the rock.
That's this one?
Yep, and that's doing that green area. You could look at the date. So there's a lot of pluses and minuses to that big machine. You can't put your chairs under your rebar. That machine's got to drive on the rebar. Then you got to pull it up and put your chairs in every time it moves. The legs can't hit the rebar. But when it came to being able to finish out really flat, big areas, it's awesome.
So is that 12,000 square foot, 10,000, how much?
Yeah.
That's a 30.
Yeah, it said it on that.
Phase right there, you're doing 15,000 square foot or more.
Yeah, no, it's a big pour. It's in a covered structure. We've got the pump inside the covered structure. See it right there on your left? Yeah, you can see the beams up above. We're inside. We don't have the skin on it, and we left out some purlins. But that machine's great. Carry on.
And I forgot about all this shit. We did that.
I mean, yeah, these are the success stories, right? These are what makes us who we are.
There you go. That's a ton of perimeter insulation right there.
What's the point of the grid on that, Richard? Is it a real structural floor?
That's a structural floor. What you're seeing, that 12 inches is carton forms that goes inside there. So it's spanning that, and it's allowing for the dirt to move up and down that much. And so we use that perimeter insulation to form these grade beams. They were also called to be hard formed, and we use that in the side of our ditch with forms on top and poured it.
And that right there above the held that?
Yeah, well, no, there was forms on the top. At the bottom, it shoves down the dirt. Yeah.
Okay. I was like, dang.
The top part's formed,
All right, got you.
but that continued down into the ditch to keep the sides of the grade beam smooth and slick. That's what he's worried about, it moving up and down. They don't want it all rough and bonding to the dirt.
You didn't have to excavate
We
the whole
didn't,
area.
yeah, so here's all the carton forms going in. So I didn't like the chances of rain, so I put plastic down and covered them with plastic. Yeah, now that's where you either line them up and they work, or you've got an RFI and you're epoxy in every one of them. Because if one don't work, they probably all don't work. Okay, now we're doing an elevated slab. I don't know how many of you have done a slab on deck. They call it a composite slab. And the reason it's composite is because of those Nelson studs. You're marrying your concrete to that steel so it doesn't pop loose from the steel. You've got to use this electromagnetic machine, and these are subcontractors of your steel guy.
That was the sound over the water, right?
Yeah. Well, no, this is building. Yeah, this is the second floor of the building, but it was the same thing on the other one. So the thing is, this is your steel guy. He's going to schedule this guy. These guys are super busy. You need to have your third-party lab, Henley, Johnston, or whoever, scheduled to be there and inspect these the same day by the end of the day. You're not allowed to stick weld these. They have to use that machine. And how they test them is they come along with a sledgehammer and knock the shit out of each one of them. If it pops loose, put another one. So the thing is, if there's one or two that's a problem, you could ask and they'll just stick weld it with a welder. But
What on centers are those on?
okay, here's the thing. There's a shop drawing for that, and it's going to be the most bizarre thing you ever saw. One beam will have them side by side every 6 inches, and then they'll go diagonal every foot, and then near an opening they'll go every 4 inches. It's he knows better than I do. When you look at that shop drawing and you'll try to figure out why did they do the center and the pattern they did, good luck. Arturo probably knows better than me exactly why, but they will submit a shop drawing.
You're still below, obviously, right? To some degree.
Yeah, because those are shoot through the deck. It goes through the deck to steel.
Yeah, that's on your steel beams.
Top flange of the beam is not just going to the deck. No, it's got to be a steel underneath.
Yeah, what they put on there is a little insulating, what do you call that little insulating deal they put around it? But it burns through the deck and then it welds to the deck. Yeah. It's a little insulating grommet that goes on it. But when you're doing a second floor, the coordination of these guys with your being a sub of your steel guy and your lab, which is a special steel inspector, don't pass it up. When I got a call Sunday to go take over the Liberty building, the owners were building it themselves. I got there, they had 2 months to get done. The first thing we find out is they didn't have any other third-party inspection. So I'm tearing the place apart. I've got to tear all the concrete out at the anchor bolt so we can see the grout under the base plate. They didn't put in the Nelson studs. The fix was to weld an epoxy bolt underneath every beam. I'm going backwards and reverse, tearing this building apart, and we got 2 months to finish.
You're going backwards.
Yeah, well, the first thing I had to do is tear it all about, document all the inspections they didn't do.
And they didn't use steel bolts in it or nothing. They used, I remember that.
Yeah.
First jobs I
Well,
worked
and you came down and did the storefront, and so here we go. We got plumbers in here setting floor drains. We've got Nelson studs going in. So on the elevated slab on deck, the Nelson studs, the lab. On second floor elevated slabs, there you are. There's
I was in the letter Johnson, Richard
yeah.
Johnson.
On second floors like this, there's no saw cutting, no saw cut control joints. Don't submit something. Okay, when you're pouring that second floor slab, don't use an auto level. Here's what happens with an auto level on the second floor slab. You keep checking the elevation, that deck has deflection. It's called out on the plans. It's going to deflect this much. The more concrete you put on it to make it get back to level, the more it deflects. The more concrete you put on it to make it back level, the more it deflects. Use a stick to shoot your grades with a nail in it. If it's calling for 3.5 inches, put 3.5 inches, 3.5 inches, 3.5 inches. If the dips in between the beams is too much, you're going to have to feather light finish them out before the flooring. Don't just keep adding concrete; it just keeps deflecting more. If you do enough, it's going to bust the seam out. So, all right, that's just.
Joe had to go, but he had a horror story about that.
Yeah.
Just keep adding more concrete. They couldn't get to the level. Well,
Yep. Don't keep adding concrete. Use a shot stick or a deck stick is what I'm saying here, not a laser level. You want to make provisions with your steel erector. What you want to do when you're erecting it above that second floor of those joists is do the bolt joist, but don't spread out all the joists. It gets in the way of the pump. So that's going to be an argument you got to have. Concrete guys, back you up. Shoring. If you just read the shop drawings and the plans, the deck normally doesn't need shoring when it's on beams like this. But you need to read it and see, because what if you needed to shore every bit underneath and you didn't? Yeah. All right. Concrete columns. There we are pouring up there. There we are pouring out on that other one on those piers over the lake. You see the safety cables, and Jose was up there tying the flagging tape to it. Here's that big job I did. Do you see all those concrete frames, all those standing up concrete columns? Do you see all that block? That's 84 foot tall, 12-inch block all the way around that theater. Not to mention all the crap that's going on everywhere else. Look at all those concrete frames. Every one of those is shoring and forms and pouring and embeds, and it just doesn't end. Yeah. So when you're pouring one of those tall concrete columns, you can only pour as tall as what your vibrator is. So you need a stinger on your vibrator 22 feet, 24 feet. You form that up for as long as that stinger is, right here. You drop that stinger down in there, you pump the concrete in. Once it's all the way up here, then you turn the vibrator on and pull the hose out. And it vibrates it in as it goes up. Then,
Do it in 2, 3 pours.
or more, then you jump the forms up. You see what's going on here? We poured this, now it's probably poured to here. We lap, jump up and go again. Yeah, I had those up, just those skinny ones, 16 by 16, some of them 8 by 24, 42 feet tall. Lord. Yeah. So I looked into splicing. There's a splicing connector that you can get. When I asked about overlapping, he wanted to overlap, if we were going to overlap, like 16 feet. I'm like, well, well, never mind. That's worse than the problem. Or my other option, the engineer said, are these connectors. They screw on, but they're super expensive. So when I looked into that, and I've got 32 bars in a column, it's like $3,200 of splice. So, okay, floppy it is. Carry on. We can fix floppy later. Okay, so that's concrete frames. You see that one's on a radius in there. This one starts way back here on a radius all the way around, gets CMU all the way with it. But yeah, that was the most fun I ever had, guys. I had to get some of those pictures in here. And you want to talk about a lot of CMU. But that's probably where I learned the most. You see that big radius beam there?
Yeah.
Yeah. Concrete paving is up next. You don't even know the embed that's in that. You can see them in the front, you can see them over there, but you can't see them all. They're all on the top of here for steel sticking up. They're all in the face of this on both sides. They're here. They're everywhere. Everything that happened there is either a good shop drawing or it sucked. This is here where we're at on this is concrete paving. This is pouring parking lot. Have a pour plan with your phases shown before you even think about getting started on this. This is something you're going to be doing dirt work as far as proof rolling and all kinds of crap. Verify your slopes for drainage for this whole parking lot before you pour. It's super important. Remember to check all your elevations conform to TAS, which is Texas Accessibility Standards, slopes at handicap parking, access to the building, sidewalks. Submit a control joint plan. I always call these soft cut saws. That's where you're cutting. As soon as the concrete's dry enough you can walk on it, you're cutting. I always call them soft cut, but it's really a brand name, soft cut, S-O-F-F. But it's important to cut as soon as you can, like he was saying, especially in the summer. That stuff is drying and cracking. Okay, so here we are doing a turn lane. You've got to deal with the city engineering and TxDOT standards and all that crap. What's going on there is a stacked curb. And I have done jobs where they have curbing machines where they just set a string instead of forms, and then that machine just follows the string around your parking lot, even all the islands. It just spits it out like it came out of a Play-Doh form out the back. But a stacked curb is whenever you order a 3 slump on your concrete and you pour that first. That way you can stack that up. You see, there's not much slump going on there.
Oh, that's actually concrete.
This is concrete. Yeah, so they're just driving along there, just pouring it out. And then they're going to come back and hand form it. But you can't do that with a slump concrete. So that truck's gonna be first with a 3 slump, then you're gonna start pouring behind him.
Fast doing that molding?
Yeah,
There you go.
well,
Working
that's
pretty
just,
fast?
yeah, they're doing it back there. No, it's just the way they do it.
There you go.
Uh,
Good job, Richard.
Till he walks.
Yeah. So, street approaches and turn lanes are normally special inspections and permits and approvals. Verify all that crap early on. Don't let it get down to the end and you figure out you need all that. This is saw cutting right away, and we're pouring the next day.
Soft cut.
What you're seeing sprayed all over there is a vapor barrier. Curing compound's what I'm trying to say. Go back up. You see all that light spray, it looks like paint, white paint. It's curing compound. That's going to help stop the moisture from getting out of the slab. Flat work, here's where you're going to have to really focus on your task. That's all that termite spray you saw on that termite plan, that's that same building. Who knows how to figure slope percentages and tasks and
Isn't it like 2%?
Two-
Quarter inch per foot, isn't it?
2% is a 1/4 inch per foot. And whenever you come out of a door on a landing, you got to have 5x5 that's no greater than 2% in any direction. You can go on, down a sidewalk that's 5%, no more than 2% cross slope on a sidewalk. But all these rules are on your plans. You can read them. Do you know how to figure a percentage for a slope? If this is 5 feet, how far can I go down here from this?
Inch and a quarter?
Yep. And that's 2%. And if he did it because he knows 2% is a 1/4 inch per foot and it's 5 feet, so it's pretty fast math. And that's the way you can do all those. But what you can also do is take 1 1/4 inches and divide it by 5 feet. 1 1/4 inches, 5 feet on your handy calculator. It'll do it, and it'll spit out the percentage. So that means that you can also do it on something as long as 64 feet, and you don't want to go down more than 5%. Now what is it? How much can you go down?
64 feet.
Yeah, now you're going to be doing a lot of 1/4 inch per foot in your head, but this is 5%.
4 times 60.
Put it in your calculator. 64 feet times 5% on your construction calculator. Just that easy. You don't even have to be a rocket science. Or you can do it the hard way, which is figure out what 5% is, which you can do on your calculator, and multiply it by 64. "64 feet, 0 inches times 5%. 1 foot 2 3/8. I'm sorry, 3 foot 2 3/8. So 64 feet, 0 times 5%. Anyway, there's
3'2".
Yep.
3'2" and 3/8".
Yep. So if you know you're less than that, you're not exceeding the 5%, you know that section of sidewalk, you're good, as long as you're not up and down too much.
That's on the lake.
Yeah. Well, that's a sidewalk
Yeah.
outside going somewhere, it might not look like a hell of a drop. It might be that you really need to go 4.5 feet, stay with the dirt, and you need to be building it up.
So if it's more aggressive, you put stairs in?
Well, that wouldn't make it handicap accessible. So what you have to do is you have to do a ramp.
So,
Now you got all kinds of rules for ramps.
you have to make it longer.
That's another way to get around it.
Yeah, snake it around.
So
You have to go down a certain amount, then you have to do a 5x5 landing, then you gotta go down a certain
you can go 8 feet, and then you got to have a landing. And then you can go 8 feet, and you got to have a landing. But all that is on your plans. You're doing a new job, or you're doing a civil job, you're doing a big job. It's right there. The thing we're talking about is have some clue to check. Make sure your concrete guy is checking. Something to be aware of. Drainage is a big deal. You're not going to lie your way out of a big water puddle out there. Yeah. So, and another thing I'll tell you, on these maximum slopes that you're going to be dealing with, don't do the maximum ever. Do a little less, because the ground does move. And then have your task inspection as soon as possible, because you wait too long, the ground does move, and you've got everything maxed out, and then any movement, and all of a sudden now you don't comply, or if it moves the wrong way. All right, this is a footing for you house builders. But it's a structural footing. We've got beams everywhere, but that pours monolithic. And that's kind of the difference between what's happening a lot on residential and commercial. Commercial, we do the piers, we do the grade beams, then we rough in all the plumbing and all the crap. On residential, you rough in all the plumbing and all the crap, and you pour everything at once. But this is more of a footing. It's just bearing on the ground, and it's got all these beams through it. And that's all the rebar that goes in this pour. Those big openings in the middle are leave-outs for the future tenant to run and do whatever they want with their plumbing to go to that main sewer drain and pour the rest of it back, because they don't have a occupant. They don't know where they're going to put their kitchen. They don't know what their layout's going to be. So we just pour the perimeter slab, which you see right there with that little 2x4.
What's the topping slab on that? 12 inches?
Right here. It's bigger than that, but yeah. It's enough for us to frame the walls out here. The rest is just all open in the building until they get a tenant and they do their own finish out.
Right.
So we've got the main sewer stubbed in there. I'm sure we got water back there. You can see it in the corner, stubbing up. It's on them. It's on them. All right, transformer pad. How many of you done transformer pads?
I worked on one out at GE something.
I got stuck doing development, and I've done bunches of them. Just about every building I've put in a transformer, but I've got stuck on that one job. We had like 7 of them. And that's when you find out the difference between pull-through transformers, where they do them in a series, and future stub outs everywhere, more development work. But on these, you need your encore inspection. It's going to call for piers under them just about always. Yeah. These piers aren't piers. This is hand dug, 6 foot deep, post hole digger, little cage. It's not like piers, but it's piers. And they work, because you'll see those things up above the ground a foot a lot when you go around. It's because they're sitting on those little piers. So you got to be careful with your window. This is your supply, and this is going into the building. So ground rod, encore inspection, lots of things. You think it's just all your electrician's going to handle it, and it's just not so.
Okay, so I can make this very quick. The paper that Richard printed out for you, I turned it into a checklist in Procore. So when you go into your project on Procore, to the checklist function, the drop down from the company tools.
All right, let me see if I can.
You're gonna go into,
We'll just say
go pull one up.
Avenue Road, and I'm gonna go to inspection.
Inspections, yep.
All right, and if I wanna just create this checklist, then I'm gonna go over here to create.
Inspection's top one.
inspection, and then, oops, we didn't pull it in.
Have you assigned it to our company yet after I made it?
Okay, we didn't assign it yet, let me just go back here. Sorry about that, we'll show you how to get that done. So, I have to just go in and assign these to all the projects.
Yeah.
And make sure that it's there, and then when you go into that inspection and you hit that create, this 6-week concrete, 2-week look ahead, and the day of pour checklist will be right there for you. You can just do it and create it in Procore.
It auto-populates and is line for line what Richard just went over. If you go ahead and click on any of them for us.
This is a 6-week.
Okay. So you'll be able to just check off saying you had it. Some of this stuff, as we talked about, doesn't apply to every job as you go through it, especially once we get to the day of. You know, you're no longer talking about, you know, if you don't have peers going on in that part of your checklist, lots of NAs available. All of the ones that had date fields by it on his checklist, I was able to put date fields in Procore, so you can go in there and do it there as well.
Is that under 4-day checklist? Go back.
Yep.
This is the
You're on 6 weeks.
this is 6 week.
Go back and see what we have on 4 days.
TV is really big when you're close to it.
Yeah, so see.
That's where you can fill it in.
Yeah,
That's
you
where your
actually
dates
fill
are.
it in here, put those dates, just like this paper. Now, Richard did mention here, and this is a great idea, have this and put it on the wall in your job trailer, but documentation and recording.
But this is the one that stays forever when you lose your piece of paper. And
No, this-
and Joe asked what happened.
This would be the one to get used to using. The other one on the wall, everybody can walk in and look at.
Right.
Yep. So this will allow you to input, you know, when you scheduled. I put it here thinking when you made contact
One
with.
of them is contact, one is scheduled. That's what's on my list.
Yeah.
Okay.
Yeah, and this date entry field is on the 1 week one as well as the day of. So you'll be able to document. You have to potentially double enter it. Not too much extra work.
Okay.
But yeah, if you have your city inspection, you can actually say what day you called and scheduled it. At least that was in my mind. We know what day the pour is.
Yeah.
So this will let us remember we called them 5 days prior to schedule.
Yeah.
And then
So if you're not doing peers, you can just leave these blank, or you can just hit not applicable and move on to, we're only working with grade beams on this board, so.
easy to scroll through and just click in. Some of them added responses on his.
Yeah.
So, you know, earth farmed,
The main thing on a lot
small
of
text
those is
response.
just reminders.
Yep.
Yeah. I personally like having a checklist. Whenever I go to do
I
it,
like the way you did this.
I cross it out on a piece of paper once I've done it, and this is just digital version.
And the benefit of this and this checklist, and I mean, it's great that it's in Procore here, because then you don't have to go, where did I have that saved, or where's my paper copy of that, or call Richard and say, can you send it to me? It's all right here in Procore, but the thing of it is if you're sitting there and saying to yourself, okay, I got this pour coming up, what do I need to do? And you're trying to think, or if you walk through this checklist, it's gonna.
Yeah, success is going to happen.
It's literally gonna hit 90% of what you're supposed to be remembering, but it's not 100%.
And everybody that's on
Every
the job
job's a
can
little
see it though
different.
too.
And if you see something that you want on it, you know, you're doing yours, and do you think we're missing a reminder? Email us. Email me. I'll just toss it on there.
Yeah.
For all of them going forward. It's
You
forever
go back
edible.
up- Go back up just a few, down a little bit, there's J bolts right there, I
Here.
didn't get a chance to. When you've got wood framing,
Oh.
nowadays there's hardware involved.
Watch out.
If you're doing wood framing, it's hardware involved now, so you've got anchor bolts, J bolts that go in for your base plate, but also for, like hurricane clips and wind ratings, that literally a clip that goes up your wall, the giant bolt, or 2 bolts in your concrete. We don't do a lot of wood framing, but it happens, and you don't wanna miss that hardware embedded, or you're gonna be epoxy in it.
Yep.
At some point, I wonder if it's even better just to epoxy it, but you can head it off, get it installed, but all the J bolts for your bottom plate, you don't wanna miss those.
No. And you don't want to let them set one in the doorway. That's hardened steel. That's a pain to cut off.
It's tempered steel.
All right, I
All right. All right, I told you I could make that short.